Hello, everybody, and you are listening to Through Time and Clades. My name is Albert.
And I'm Joan.
All right. Well, today we are going to continue my series on a bird evolution, uh, and I think it's going to be a pretty interesting one because these are both very interesting groups. But before we get started, how are you doing this week?
I've been doing fairly well. Not too much to report. I've just been kind of overjoyed by all the responses from the finale of Humanity of Prologue, and
Hmm.
just kind of hearing what some of our viewers have commented and what they had to say, and responding to those. Um, just all good things, but nothing too much else otherwise. What about you?
Uh, yeah, not too much to report for me either. Yeah, mostly just continuing work on the PhD and related things. Yeah, it's been an all right week, I think. Like I didn't get as much done as I wanted to, but or I yeah, in terms of um the actual writing of the PhD, but I still took care of like a fair bit of things that had to be done. So yeah, I'll put it that way. So yeah, it's kind of stuff is happening, and hopefully I'll finish it at some point.
Oh, excellent. Yeah, hopefully.
But yeah, for now, I think we'll have a lot of fun talking about these birds. So we are going to talk about two different groups today, the falcons and the parrots. And the reason we're going to talk about them together is that they are surprisingly actually quite closely related to each other. Um, so first of all, I'm just going to say that this episode title is probably my personal favorite out of all the ones I came up with for this series. I think it's quite appropriate. You can make your own judgment on that. Um, and yeah, I also went to some lengths to try and get a photo of a falcon and a parrot in the kind of same picture together for the title slide. Um, Now, even though in this particular photo, it might seem that these two birds are being pretty chill sitting next to each other, it's actually not such a friendly kind of family reunion here. So, this is actually part of a whole sequence of photos. And what is actually happening is that the pink parrot, this cockatoo over here, or specifically a species called the galah, is actually trying to get the falcon to go away because falcons eat other birds, so other birds tend not to like them very much. Whereas the falcon, which is an Australian hobby in this particular photo, this particular species here, is kind of ignoring it. So not really phased by the cockatoo trying to chase it off. But yeah, that's kind of what's happening here. But it certainly is a very appropriate image for this episode, I think. So yeah, do you have anything to add before we jump in?
Oh, I mean, it's definitely a fantastic photo, and I think it's it kind of just makes me think of something really randomly.
Sure.
You know how in like pop culture, sometimes they have like bird characters that are talking, and like maybe they have like let's say a seagull eating like a bucket of chicken or something,
Oh.
and then it's like, oh my god, you're engaging in cannibalism. That's the birds you're eating. You realize that, right? Like, you ever wonder like how weird that is?
Yeah.
Like birds are not a species. It's
Right.
not technically cannibalism if the seagull eats a chicken.
Right. Right.
Really, since we have a whole collection of birds called birds of prey that eat other birds. So like,
Right.
but we don't talk about that when it's that context.
Right, right. Yeah, that's something that definitely gets me too. Yeah, like people seem to commonly in pop culture consider like birds eating other birds to be, cannibalism, but that's obviously not necessarily the case. Like, oftentimes it's birds eating other species of birds, and yeah, it's not really much different from us eating other types of mammals, which we do all the time. So yeah.
Exactly. Yeah. No, that just came to my mind.
Oh,
Just
totally.
things
Yeah,
to laugh at about pop culture.
it is a pretty oddly common misconception, but yeah, no, yeah, no. Falcons eating parrots is not cannibalism, um, and yeah, it's that's a rather improper use of that term, but and nothing really unnatural about it. Um, but yeah, we will get into more detail about how falcons hunt and kill other birds later in this episode. Um, but first, let's go to the first slide in the presentation and kind of put these groups into context. So for the past, few episodes, we've been looking at a group of birds called Teleraves. So this is a group of mostly tree-dwelling and some ground-dwelling birds, uh, kind of accounting for a big chunk of bird diversity today. Um, and it's taken us many, many episodes to kind of get through them, and we're still continuing with that. Um, Now, within Teleraves, there is a particular group called Australaves, which is a group pictured on the slide here. Um, and the reason that they are called Australaves is that this is a name meaning southern birds, and this is based on the hypothesis that this particular group originated in the southern hemisphere. Um, which seems plausible based on the distribution of the living members of the groups. Um, but as we discussed in episode, I think it was 11, perhaps, as we discussed in a previous episode, um, kind of the modern distribution of bird species can potentially be misleading when trying to figure out the ancestral distributions of these groups, because in many cases, if we look to the fossil record, it turns out that a lot of these groups had perhaps wider distributions in their evolutionary history compared to their current day distributions. However, I would say with the case of Australaves, it is probably at least plausible that they could have originated in the southern hemisphere. We do find fossils of a lot of these groups in the southern hemisphere very early on, and as we shall see um, regarding some of these groups, specifically like the parrots, there is pretty good reason to think that at least the modern the crown groups of these particular lineages did originate in the southern hemisphere. But we'll get to that later. Um, within Australaves, we already met one of these groups, the Caryomyforms, which were the subject of the last episode. So today, the Caryomyforms consist of only two living species called Seriamas that live in South America. But as we saw in the previous episode, they were once much more diverse, including groups such as the terror birds, which in many cases were apex predators in their environments. Um, and they were once, the Caryomyforms in general, they were once a lot more widely distributed, with members living in North America and Europe as well. Now, the three remaining groups that we haven't covered yet are the falcons, parrots, and passeriform birds. So the passeriforms are the songbirds and their relatives. Now, the passeriforms are such a massive and diverse group that I decided to save them for the next episode. But today we will cover the falcons and the parrots together. So, alright then. So the falcons, parrots, and passeriforms, they form a group within the Australaves, and on the next slide we will introduce that group. This group has a rather long name called a eufalconimorphs, which is quite a tongue twister of a name. Sorry, I didn't name it. Um, but basically, what it's intended to mean is that "u" means true, and falconimorphs are the falcon morphs, basically, the falcon-like birds. Traditionally, the name falconimorphae was used for what was thought to be like an assemblage of closely related falcon-like birds, so including not only the falcons themselves, but also things like the hawks and eagles, for example. Um, However, as we now know, in large part thanks to genetics, the hawks and eagles and the falcons are not actually all that closely related. They are both members of this group, Teleraves, but they themselves are not each other's closest relatives. And so when it was found that in fact the falcons are more closely related to the parrots and the passeriforms, some people decided to call this new group, this newly recognized group, the true falconimorphs. So hence eufalconimorphae. So that's where that name comes from. Yeah, this is a rather unexpected group that was first recovered using genetic data. Um, but it should be mentioned that even in the past, even rather historically, like in the 1970s or so, there already were people who, looking at the morphology of falcons compared to other birds of prey, were already saying, you know, there are some pretty notable differences in their anatomy between falcons and other types of birds of prey. So maybe they don't, in fact, form a clade. Um, but it has been tricky to find out uh, what they actually are closely related to prior to the use of genetic data and very large scale genetic data at that. But nonetheless, we now do have a very large scale genetic sequences for many of these modern birds, and so analyzing these sequences, we consistently find that eufalconimorphae is supported as a clade. So at this point, we're pretty confident that yes, the falcons, parrots, and passeriforms are each other's closest relatives, as strange as that may seem. Now, so it's because eufalconimorphae is such a newly recognized group, we haven't really identified many kind of anatomical features that seem to characterize them. But people have noticed a very interesting kind of similarity between falcons and parrots in terms of how they replace their wing feathers. And so the way they do this is what is called bidirectional molt. So in most birds, when it's time to replace their wing feathers, the more common method is to kind of replace the feathers close to the base of the wing and then kind of move in a sequence outwards. So a feather closer to the base of the wing sheds, and then as that one is regrowing, the next one that's closer to the tip of the wing, the outer edge of the wing, that one sheds and then starts regrowing, and then the next one does that, and then so on and so forth. But in falcons and parrots, there's a very odd kind of method of replacing the wing feathers, and that is basically a feather from the middle of the sequence kind of drops out first instead, and then the feathers kind of replace in a sequence that moves bi-directionally in two directions. So a feather from the middle drops out, and then the two feathers next to that feather start dropping out and getting replaced, and then the two feathers outward and inward from that then do that. So that's basically what's being shown in the figure here. So there are kind of two regions of replacement in the wing. The primary feathers, the feathers on the of the hand towards the tip of the wing, they do this kind of bidirectional molt sequence. You can see here on the top is showing P5, meaning primary feather 5 and primary feather 4 are the first feathers to drop out, and then they kind of move outward from there. Whereas there's a kind of separate sequence that's going on with the secondary feathers, the feathers along the forearm, where in this case S5, secondary feather 5, drops out first, and then it kind of moves outward from there. And on the bottom, it's pretty much the same deal, but slightly different feathers are dropping out first. But in any case, they're both examples of bidirectional wing molt, which is very rare in birds, and is a very odd similarity between falcons and parrots, which now makes sense now that we know that they are in fact closely related. Now in passeriforms, this trait is lost. They seem to have reverted back to the kind of the type of sequence that is more common in other birds, where it starts from the base of the wing and moves outward instead of a bidirectional kind of molt. But still, it seems quite likely that this is ancestral to this group, eufalconimorphae. All right. Do you have anything to add to this?
Not particularly, but that's kind of a fascinating observation.
Yeah, definitely. People have started to, I think, pay more attention in recent years to the potential phylogenetic significance of molting patterns. And there are some interesting observations there to make. So yeah, definitely you can find evidence of kinship in sometimes the rather unexpected places. All right, so today, as I mentioned earlier, we will deal specifically with the falcons and the parrots and save passeriforms for the next episode. But first, we'll start with the falcons then. All right, so falcons are a group of raptorial birds. They are primarily hunters of other vertebrates, and they are the last group of ancestrally raptorial teleravians that we are going to be covering. So we talked in episode 10 when we introduced teleravies and raptors about how it seems plausible that teleravies as a whole probably descended from a carnivorous predatory raptorial bird. And we saw how several groups seem to have retained a raptorial lifestyle from this ancestor. And so we met the accipitromorphs, the vultures and hawks and eagles, and we met the owls, the strigiforms, and we met the caryomorphs, the seriamas and terror birds and their kin. And finally, we have the fourth group that we now recognize as raptors, the falcons. There are over 60 living species of falcons, so they're a fairly diverse group. They're not as diverse as the hawks and eagles and kin, but they do pretty well, especially considering that falcons can be found similar to the hawks and eagles worldwide on pretty much every continent on Earth, except in the modern day in Antarctica. But even in Antarctica, we actually know of a possible fossil falcon from the Eocene of Antarctica, from before Antarctica was completely covered in ice. So it seems that they might have lived in Antarctica long ago, back then. So perhaps they did have an essentially worldwide distribution once upon a time. In fact, the peregrine falcon, species pictured here, and one of the most famous falcons, it alone is found on, pretty much every continent on Earth except for Antarctica. And it is another contender for possibly the most widely distributed wild bird on Earth. And we talked before about some other candidates for that role. One commonly cited example is the osprey, which is a fish-eating basically relative of hawks, which also is very widely distributed, essentially worldwide, but it depends a little bit on kind of whether you consider the osprey to be one species or two. The Australasian populations are considered by some to be a separate species. And another contender is the barn owl. And again, there is some dispute over how many species should be considered there, because some people consider there to be several different species of barn owl, that, in which case the range is kind of split up between them. But nonetheless, it is quite notable that all of these are different species of raptors, so kind of the raptorial lifestyle can be a very successful one in terms of being very adaptable to many different types of environments. And the peregrine falcon is certainly yet another example of that. In terms of the time range of their fossil record, we'll talk a bit more about fossil falcons later in the episode. But there are possible falcon fossils, or the stem falcon fossils from the Eocene, and definitely by the Miocene onward we find falcon fossils. We'll talk a bit more about that later. Now, in terms of environmental preference, falcons tend to prefer open habitats, so places like grasslands and such. And there are some exceptions. There's a group that we'll meet later called the forest falcons, which, as their name suggests, live frequently in forests. But for most part, falcons are open habitat animals. And kind of probably relating to this is that many are fast-flying predators. There aren't many places to hide out in the open, and so to catch their prey, falcons have to be very, very quick and strike very, very fast and surprise their prey before they can react. So that is a very common kind of hunting strategy that falcons use, and rather famously, the peregrine falcon in particular is often said to be the fastest animal on Earth. And that is because the way that it hunts is truly spectacular. And what it does is it flies high into the sky. It uses several different types of hunting methods, but probably the most famous one it uses is what we call the stoop. And the stoop is this very fast diving flight that it performs while it's hunting. So it flies high into the sky and looks for prey up there. Oftentimes it'll fly with its back to the sun so that its prey can't see it coming. They don't want to stare into the sun, right? So it does that, and when it spots a potential target, it suddenly dives down very quick. It kind of folds its wings back, making itself very streamlined, and then just falls through the air at a extremely high speeds, reaching over 300 kilometers per hour. And then with that, it catches up to its prey, hopefully before it can react. And usually, what it does is it strikes its prey with its foot as it catches up to it, which can potentially cripple or kill the prey on impact, and then it catches the prey as it falls. Yeah, very spectacular kind of hunting method, and I'm sure you can find lots of videos showing this. There's a lot of cool kind of animal documentary footage where people go skydiving with peregrine falcons.
Oh,
Yeah, yeah. A lot of time, like people would take a piece of meat or something with them while they're skydiving, and they'll jump through the air and then let the falcon kind of catch up to them in a stoop. It's really cool. And in doing the stoop, the peregrine falcon seems to be indeed the fastest recorded animal on Earth. Now, they are not the fastest animals in level flight. So flying in a in a horizontal kind of flat line, they are very fast in level flight, but they're not the fastest. Currently, there are a number of contenders for the fastest animal in level flight. Among birds, the swifts, for example, seem to have the current record, reaching over 100 kilometers per hour in level flight. Some of the ducks might be able to fly at comparable speeds, and somewhat surprisingly, there's a species of bat, the Mexican free-tailed bat, I think, that has in recent years been recorded flying at over 100 kilometers an hour. So that is also potentially one of the fastest animals in the world in level flight. But with the assistance of gravity, definitely the peregrine falcon seems to be the fastest overall when it goes into that stoop. So yeah, a really amazing animal. However, not all falcons hunt in this kind of manner. Not all falcons rely on speed in this way. We will look at some of the different groups of falcons on the next slide, but there are other types of hunting strategies that falcons use. For example, there's a group called the caracaras, which seem to be a lot more generalist kind of predators. And if you look at a caracara, it doesn't look very much like other types of falcons. So other falcons, their wings are kind of sharp and pointed, which is the type of wing you'd need to fly at very high speeds. But in caracaras, they have these kind of rather long and broad wings of a soaring bird, and they're a lot more sedate in terms of how they forage. They kind of soar over the landscape. They scavenge a lot, eating a lot of animals that are already dead, but they're not picky. They'll eat just about anything. Um, but even so, I think it's fair to say that falcons are probably most famous for their kind of fast flying hunting strategies. Um, and relating to this is a rather notable difference they have from things like, say, hawks and eagles. We talked about how hawks and eagles, one of the main ways that they kill their prey is a method called raptor prey restraint. And what
mhm.
they do is they try to pin the prey to the ground with their talons and just hold the prey down while the prey struggles and kind of tears its own wounds open. And eventually, as the prey kind of weakens from blood loss and shock, the raptor can then start feeding. Yeah, it's rather gruesome. Whereas falcons don't really do this. Falcons have a very different method of killing their prey, and unlike hawks and eagles, they don't have a particularly enlarged kind of inner talons on their feet to help them with this. So as mentioned earlier, with things like the peregrine falcon that strike really fast, a lot of the time that initial impact strike is enough to basically discombobulate the prey and prevent it from going anywhere, pretty much. And so usually when that happens, if the prey is not killed on the first strike, um, what the falcon will do is that they will try to finish the prey off as quickly as possible by using what is called a tomial tooth. Now, this is not an actual tooth like we'd see in an animal that actually has teeth, but it is a sharp projection on the upper bill. And the falcon will use this projection to kind of sever the neck of its prey if it is not killed on the first strike. Um, and so falcons kind of prefer to finish the prey off as quickly as possible instead of this kind of long, drawn out process that the hawks and eagles tend to use. So that's a pretty notable difference, and this is primarily found in the kind of fast flying falcons that strike prey at high speeds. A characteristic in which they are similar to hawks and eagles is that female falcons tend to be larger than the males and sometimes much larger. Um, and we talked about this when we talked about the hawks and eagles. And it's also the case in owls, incidentally, or most owls at least. And probably what this relates to is that the female does most of the nest guarding and kind of, protection of the young, and that's why they tend to be larger to kind of help them in this endeavor. Um, and that also seems to be the case in many of the falcons. All right. So I guess in terms of personal experiences with falcons, I definitely have seen them occasionally. Um, Peregrine falcons, as you might have heard, um, have made a really nice comeback in recent decades. So they used to be one of the groups of raptors, which I think we talked about this briefly in the hawk and eagle episode too. Um, uh, a lot of raptors used to be threatened by the use of a pesticide called a DDT. Basically, what happens with a lot of these environmental toxins or toxins that get out into the environment is that animals close to the bottom of the food chain might only consume these toxins in relatively small amounts, but animals at the top of the food chain, these apex predators like these raptors, end up eating a lot of these, other animals. Uh, they end up accumulating a lot of these pesticides in their bodies, and that's obviously really bad for them. And in the case of raptors and other birds, a very nasty side effect of DDT was that it made their eggshells rather crumbly and very fragile. So the birds couldn't even sit on the eggs to incubate them because they just crushed the eggshells, and of course that wasn't good because they never have any babies that successfully lived to adulthood. And because of that, a lot of raptor populations started to decline. But fortunately, now that a DDT has been banned and isn't really in use anymore, a lot of raptor populations have made a rebound, and among these are the peregrine falcons, which, as it turns out, have survived very well in a lot of anthropogenic environments. Places like cities are actually very good habitats for peregrines. Because they have these, skyscrapers are basically like cliffs, which prior to urbanization, peregrine falcons often lived on, and they still do, but they often live on seaside cliffs, coastal cliffs near the sea, where they can hunt for seabirds and other types of birds found in those environments. Um, yeah, and skyscrapers in cities are basically like cliffs, so they're good nesting spots for them. And there is often quite plentiful prey, such as pigeons, for example. Lots of pigeons in cities, and so falcons, peregrine falcons specifically, have done pretty well in urban environments, and certainly in many of the British cities that I've lived in. So in Bath and in Cambridge, where I am right now, there are local nesting peregrine falcons that people can see just wandering through the city. So yeah, it's pretty cool to see these apex predators just living among us here. How about you?
In terms of falcons, oh, I wish I
Mm,
could see peregrine falcons,
right.
but the kind of area where I'm at is not really favorable to them
Yeah.
specifically. The one falcon that I see the most, and I wouldn't say the only falcons. I'm sure there's been like occasions where I've seen other
Right.
species, but I don't, and they're not coming to mind. Would be probably be the American kestrel,
Yeah, yeah.
which I think is smaller than a peregrine falcon,
Right, right.
and it has like a different coloration. It's more like orangey on the wings.
Hmm.
Um, yeah, I'm used to seeing them like on the sides of the road, like whenever we're driving around, like they're hanging
Yeah,
out on a fence post or something, just eyeing out, keeping a lookout for food. Um, although I do see I do tend to see hawks more than I do
right.
falcons.
Yeah,
Like whenever I see a falcon, it's usually a special occasion for
right.
me.
Yeah, definitely. I know back when I lived in Maryland, for example, I did not see peregrine falcons at all. Um, yeah, it's definitely an environmental thing. Yeah, kestrels. Yeah, I definitely do see occasionally, but of course not usually in the middle of cities. But yeah, if I'm riding in a car or a bus like through the farmlands and places like that, you do see them. They do like open habitats like that. Um, and yeah, kestrels are very cool because their hunting strategy is basically they'll hover over these open fields, just beating their wings and staying in one spot. And they mostly hunt for small mammals in the fields, and apparently they are able to see urine trails left behind by these small mammals because the urine trails of a lot of these small mammals they reflect ultraviolet light, which can be seen by the kestrels, and so they are able to kind of track their prey in that way.
Oh
And then when
wow!
yeah, yeah, pretty amazing. And yeah, so when they see a little mouse or a vole or something, they'll quickly drop down from the sky and yeah, bring death from above. Yeah, kestrels are mostly you're right. They are largely smaller than peregrines, but certainly very effective hunters in their own right. So yeah, I have seen the American kestrel occasionally under those circumstances, and over here I've also seen the Eurasian kestrel or common kestrel occasionally as well. Now I think those two are not actually closely related to each other within the falcon family tree. So it really the term kestrel is not a phylogenetic one, but more of a ecological or morphological term of these relatively smallish falcons that hang out over open fields and catch prey by hovering. But yeah, definitely all falcons are pretty cool for sure. And I think even though peregrines are relatively easy to see here if you know where to look, it's always a special occasion to actually see them.
Yeah, and I wish I could see them like on the hunt.
Mhm.
I haven't had that opportunity like I have with hawks.
Right, right.
Mm. Although I love the videos of the falcons like in the air, like when they spotted something and their head is just in one place
Oh
while
yeah.
the whole body is flying around. I mean that's I think that's pretty much a meme at this point.
Oh, right, right.
It's still cool that they have like that.
Stabilization. Yeah.
Yeah.
Yeah, I've never I've seen the falcons around, but I've never actually seen them like hunting anything. Uh, but yeah, that would be it would be cool to see that in person. So hopefully I will at some point since they are found around here. Um,
Mhm.
but yeah, all right. Let's go on to the next slide where we'll look at some of the specific groups of falcons, falcon phylogeny. So basically, living falcons can be split into three major groups. And so one of these groups is the forest falcons, and these are found mostly in South America. Um, and as their name suggests, they are often found in forests. So the one pictured here, the laughing falcon, is actually found in more semi-open habitats. The laughing falcon, in fact, is a specialist on hunting snakes. Its scientific name, Herpetotheres, it basically means snake hunter, and I know it is revered in local cultures because of that, because of its snake eating habits. Whereas the other forest falcons, they're kind of similar to the what we called the accipiter hawks when we talked about the hawks and eagles. So things like the sharp-shinned hawk and the Eurasian sparrow hawk and the goshawk. Um, they kind of have a similar hunting strategy to those types of hawks. They'll hang around in forests, so dart through the trees, going after their prey. Sometimes other birds, but I don't think they're too picky though. They'll go after pretty much any smaller vertebrates. And the forest falcons are mostly a group of relatively smaller species of falcons, whereas the caracaras, the next group, this is a group that includes some of the larger falcons, and they're an interesting group because they don't really look like other falcons at all. I already kind of mentioned this earlier. Yeah, they don't really have like a kind of very distinctive long and pointed wings that other falcons have. They're a lot more like falcons trying to be vultures. They'll soar around kind of rather slowly on their rather broad wings and look for uh, just about anything. They're not picky in terms of their food. They'll eat dead bodies, but they'll do a bit of hunting as well. And they'll even eat things like garbage or a little bit of vegetation, things like that. So yeah, they are kind of generalist feeders.
That's really interesting. I can't think of a bird of prey going after plant matter as a
Yeah.
food source.
Yeah, well, we have talked a little bit about some species like the palm nut vulture that feeds regularly on like fruit and things, but yeah,
Oh yeah, true.
it's not super common. It definitely is fairly unusual as a behavior, and yeah, the caracaras are definitely a really interesting group in terms of that. Something else I'll mention regarding caracaras is that there's a particular species of caracara called the red-throated caracara,
Hmm.
which is very unusual because it is a specialist in feeding on wasp larvae. Um, and the way that it hunts for wasp larvae is interesting because it used to be thought that they kind of secreted a sort of substance or something from their feathers that would like sedate the wasps and prevent them from stinging. But then people started doing more detailed observations of how they actually hunt for wasps, and it turns out that their strategy is a bit less elaborate than that. And well, what they basically do is they basically use a hit and run tactics. They'll just fly in and knock a wasp nest off the tree, and then quickly fly away before the wasps can retaliate. And then eventually the wasps just kind of hang around. They're angry, but they're like, oh well, the nest is doomed, so there's no point in staying here anymore, and they leave. And so the caracaras come in and feed on the wasp larvae that are left behind.
That's so sneaky.
Right, right.
I've never heard a hit and run attack strategy. That's just I'm just picturing that in my head. That's it's so funny.
Yeah. It's like, oh, what do you do? Do you have like thick skin to protect you from wasp stings, or do you secrete some weird substance? And then no, I just knock the nest down and fly away. It's
Like
like
it's literally like what people do to get rid of wasps. They just
right, right.
throw a boot at it and then run away.
Yeah,
The bugs are gone or something.
right, exactly. So, yep, that's a really interesting one. I actually have a no, this is kind of beside the point, but I have a T-shirt um, that depicts a red-throated caracara, and it has a slogan on it that says "Scream loud and eat wasps." So that's
Oh, that's awesome. I love niche T-shirts.
yeah, yeah, it's funny. Um, so yeah, definitely quite a bit more variation in kind of feeding strategies than you might expect. Now, the falcons that we typically think of when we think of falcons, I guess, are appropriately I call them here the typical falcons, and so they represent kind of the bulk of falcon diversity. And yeah, they include things like the peregrine falcons and the different lineages of kestrels and many others. And so they're the ones that have the very distinctive, very falcony shape that tend to hunt by surprising their prey at high speeds, and yeah, very very fast flyers. Um, so yeah, those are the three major groups of falcons, and I introduce them here not only to show their ecological diversity, but also because we actually have a fossil representatives of all three of these major lineages. So yeah, that's pretty cool. I guess with that, we can go on to look at some of the fossil falcons. What do you think?
Sure.
All right, so On the next slide here, first up we have a falcon from the Miocene of Argentina. It is called a Thigornis, and currently there are two different species that have been recognized, although it is not clear whether they might be, just maybe different sexes of the same species or slightly bigger and smaller individuals of the same species or something like that. But in any case, Thigornis is known from some pretty good specimens. There's a skull pictured on the slide here in different angles, and many other parts of the skeleton are known as well. If you were paying close attention in the last episode, the name Thigornis might be familiar because it turns out that there was a specimen of Thigornis that was thought to be a stem seriema, but it actually turned out to be another specimen of this falcon instead. So yeah, kind of an interesting taxonomic mix up there. Now, Thigornis, it is currently thought, based on phylogenetic analyses, to actually be a member of the forest falcon lineage, and so that is quite interesting. It is actually a bit bigger than the living forest falcons. So most of the living forest falcons are about, let's say, crow-sized or smaller, whereas something like Thigornis, it got up to the size of, let's say, a chicken or so, like over a kilogram. So it's a good bit bigger than its closest living relatives. And living in the Miocene, it was probably living at a time when habitats were starting to open up. So probably its larger size was an adaptation to kind of hunt in these more open environments.
Hmm.
But even so, it seems that it eventually, didn't make it to the present day, or didn't really evolve into anything that made it to the present day. And so today we only have the smaller species of falcons, forest falcons, that are still alive. So yeah, but still, it's not common that we get such a completely known raptor fossil. So this is a pretty significant genus. Do you have anything to add before we move to the next one?
Not particularly, no.
All right. Now, the caracaras are also known from a number of extinct species, as we'll see on the next one. And so I give a couple of examples here. These are some of the larger extinct species of caracara. So on the left here, we have Caracara telustris from the Holocene of Jamaica. It's a one in the middle, labeled with the letter B. And you can see that it has much longer. This is a tarsometatarsas, so the foot, much longer foot than living caracaras. And what's interesting about Caracara telustris is it might have actually been flightless, or at least had reduced flight capabilities, because we do have some bones from the forelimb and the shoulder girdle of this species, and these elements are shorter and more slender than you would expect for a bird of its size, and so it probably wasn't much of a flyer, and so this Caracara seems to have kind of taken the kind of next step on from the typical kind of Caracara foraging style, where they tend to, pick up food items from the ground and just kind of walk around on the ground a lot, and kind of reduced its flight capabilities, probably because it was living on the island of Jamaica. So yeah, an almost flightless falcon is a pretty almost contradictory kind of concept. But here we go. Here's an almost flightless falcon, Caracara telustris. Yeah, it's one of the biggest caracara species we know of, but it is not the biggest. There was a bigger one called a Caracara major from the Pleistocene of Uruguay, and that's labeled number 1 on here. These are coracoids. A coracoid is a bone in the shoulder, which we don't have, but birds do. And you can see that Caracara major was much bigger than these other. These are all, I think, examples of modern falcon coracoids, and so they're much bigger than any living falcon. And perhaps surprisingly, there was even bigger species of Caracara that once lived in Argentina. And it is not known from very complete remains, so it hasn't been given its own species name. But it was it was slightly bigger than even Caracara major, and so that seems to have been the largest falcon that we currently know of that ever lived. So yeah, the Caracara fossil record is also pretty rich. And these are just two examples that I gave here, but we actually have a number of other fossil species of caracaras. Like there's one known from the La Brea tar pits, for example. And there's one known from the Falkland Islands, which is pretty surprising because we don't have many bird fossils there, or many fossils in general, really. And I guess I did mention this earlier, but the caracaras are an American group, so they're found in both North America and South America, but they don't get very far north into North America, so they're kind of found in the southern United States, but not much further north than that. And it seems that they've been around for a while because we find all these different fossil species throughout the Americas too. All right. Do you have anything to add to this?
I think it's interesting that pretty much almost every bird group has experimented with flightlessness or near flightlessness at some point in the past.
Right.
So I think it's kind of funny to think about like a possible flightless falcon, which I mean, wouldn't that technically kind of be like a terror bird a little bit?
A little bit, yeah, yeah. That's a good observation there. Yeah, wouldn't surprise me. That it might have fed something like a terror bird did. Um, so definitely, yeah. It is quite interesting that even though so many different bird groups have experimented with flightlessness, that we still do see a tendency for some groups to evolve flightlessness more than others. And
Yeah.
yeah, and of course, it is certainly not very common in falcons, since Caracara lustris is really the only candidate that we know of. But of course, in groups like rails, for example, we see that happening a lot, as we talked
Mhm.
about in the gruiform episode. We see it happening a lot in waterfowl and the ducks and their relatives, and of course we saw that in the paleonate birds, ostriches and their kin, where they lost their flightlessness multiple times. So yeah, it is an interesting pattern to see, not only the fact that flightlessness is widespread, but also why does it happen in some groups more than others? And I think we talked a little bit about this already in the rail episode, so it's not really the place to talk about it here. But yeah,
Mhm.
no, the evolution of flightlessness is fascinating. All right. Um, let's go to the next slide, and we'll meet a few fossil or extinct typical falcons. Um, and here we also know of a number of species. And the first one we'll meet here on the left is a one from the Pleistocene of Cuba that's been called the Cuban kestrel. Um, the scientific name is Falco karachkini. Um, and here, what you're seeing here is that the middle bone in each of these comparison images is a bone from this extinct kestrel. Letter A shows a series of vertebrae that are fused together, which, as it happens in some birds, whereas the other bones shown on here are bones of the hind limb. Um, and what is interesting here is that the Cuban kestrel uh, was not um, was not bigger than the comparison being used on the right in each of these images. So the rightmost bone in each of these images belongs to a small falcon called the merlin, um, which which is actually a species I've seen. So that was a pretty memorable experience. So I was doing geology field camp at the time, and we went out into the wild. It was one of those weeks where we were camping out in the field, and just every day we would go out and check out these rock formations, and basically we were trying to create these geologic maps of the region as our kind of exercise during that program. And at that site, there were these like huge rock formations that are really tall, like rising up from the ground, and they were really spectacular. And at that site, there was a pair of these small falcons called these merlins that were nesting probably at the site, and so they would hang out on top of those really tall rock formations, and they didn't really like our presence, to be honest. Like when we would pass by, for example, they would kind of scream at us and fly overhead. Yeah, but it was really cool to see them. Merlins are are a species of rather small falcon, but they're quite aggressive. They are known for basically trying to chase off any other bird of prey that comes into their territory. Basically, it is said that basically if you see a small falcon high in the sky and you see it kind of take a dive at a larger raptor as it flies past, it is probably a merlin. As one of the ways you can recognize them. So it's yeah, they're feisty, feisty little birds. And they often hunt other small birds. They're also very good at catching dragonflies as well. So yeah, they're very cool little hunters, and it was a really amazing experience to see them as part of an already amazing experience at geology field camp. But anyway, that's kind of beside the point. So what is being shown here is that the Cuban kestrel, in terms of overall body size, was actually not really any bigger than the merlin. They were about the same size, but the Cuban kestrel has longer hind limb bones, and so it has been suggested that maybe the Cuban kestrel was a species that was specializing in hunting on foot, so another kind of more terrestrial kind of falcon species, walking around and catching prey on the ground. That would be quite unusual, and probably it did this because it was another island species living on the island of Cuba. There is actually one species of typical falcon alive today that often hunts on foot, and that is the brown falcon of Australia. And yeah, it is still a very good flyer, but it will often kind of walk around on the ground and kind of pounce on prey while it's walking. So yeah, it seems that maybe the Cuban kestrel might have used a very similar kind of method. And actually, while I've mentioned the brown falcon, I might as well say this because I don't think I mentioned this during the hawk and eagle episode, and that is the brown falcon is one of the Australian raptors that has been observed basically intentionally spreading bushfires, basically, which is wow, that's an incredible kind of behavior. So I guess as a bit of background, a lot of predatory birds that live in areas that often have wildfires will use those fires as a way to hunt for prey, because what they'll do is they'll kind of stay ahead of the flames, and as you know, a lot of small animals are trying to escape from the fires, so the predatory birds will just come and eat those small animals, and because they can fly, they can stay ahead of the flames pretty easily, and you can see this as a pretty common sight in a lot of these ecosystems where wildfires are common. And well, it turns out that in Australia, it has been observed that there are some raptors that will not only, use these fires as a sort of opportunistic kind of thing. They'll actually intentionally spread fires. They will take burning sticks and things from fires and then kind of drop them in other places, and then start new fires, and then use that as a way to catch prey. So yeah, fire using dinosaurs.
That's incredible.
Yeah. Now, fortunately, they haven't, as far as we know, learned to make fire yet. But still, goes to show what potential birds have, right?
Yeah, they're getting up there.
Right, right.
Now, I guess something just came to mind that
Yeah.
I don't think I've ever thought about really before. With different birds of prey
Hmm.
in certain parts of the world, like
Yeah.
obviously, like here in North Carolina, I've seen hawks and I've seen eagles
Yeah.
and I've seen falcons. Do they kind of have a way to, I don't know what's the right word for this, just like not compete
Yeah. Like
with each other?
partition their niches, I guess. Yeah.
Yeah.
Yeah. Yeah. There is to some extent, definitely. So yeah, different hunting strategies for one, and different habitat preferences and different prey preferences can often be found in birds of prey that live in the same regions. Yeah, so I guess in eastern North America, for example, let's think what some of the common raptor species are. Yeah, you have of course a red-tailed hawk, one of the
Mhm.
most common ones. Yeah, and that's a mostly kind of open habitat hunter, mostly feeding on small mammals. Um, and yeah, they'll hunt other things too, but definitely I think small mammals are the primary part of their diet. Um, and uh, and then let's see, what else do you have? But then you have say sharp-shinned hawk and Cooper's hawk, which are more forest-dwelling hunters that are hunting other birds. Um, And then you have, of course, American kestrel. So that's also an open habitat, a small mammal hunter, but it is much smaller than the than red-tailed hawk. So I would imagine that they are capable of taking down very different types of prey. For example, a red-tailed hawk might go after squirrels more often, whereas the kestrel might focus more on voles and mice, for example. And then, of course, you have the owls, which are partitioned by being nocturnal, so they hunt when the diurnal raptors are asleep. And so,
Hmm.
in that way, yeah, a lot of different raptor species can coexist in the same region for sure.
That's fascinating to think about because I mean I remember our discussions about just a couple tens of thousands of years ago in the Pleistocene where there were a lot more than that.
That's right.
But
Yeah. Exactly. Yeah, it would be fascinating to find out like how all of those different Pleistocene raptors were kind of partitioning their niches and what yeah, how they might have been different from each other. Yeah, it's incredible. Yeah, hopefully with things like isotopic studies maybe we might be able to get some sense of what they were doing. I definitely think there's a lot of research that could be done on those.
definitely, I agree.
But yeah, in Australia you have the brown falcon that is known to do this fire spreading behavior, and also a couple of species of kites that do that as well. So yeah, that's definitely a really incredible kind of behavior. But anyway, yeah, back to the extinct falcons. We have the Cuban kestrel, which seems to have been a mostly terrestrial hunting small falcon, which is pretty odd and interesting. And then we have this other species I picture on the right here. This is a Falco huzonensis from the Miocene of China. And the main reason I show this species here is because it is known from an almost complete skeleton, which is pretty rare for a bird fossil, especially a raptor fossil. This is a really amazing specimen. And yeah, this is definitely one of the most completely known fossil falcons that we have. It's known from the all the way in the Miocene. We think that this particular fossil site probably records a fairly open and arid habitat, which is fairly similar to the types of habitats where we often find falcons today. So that's pretty consistent. And Based on phylogenetic analyses, it seems that this extinct falcon was probably pretty closely related to the things like the common kestrel of Eurasia today. Something else that's interesting is that we actually have gut contents preserved in this specimen. I think they are kind of circled in an oval on the kind of schematic on the bottom. It's kind of faint, but maybe you can make it out.
Yeah.
So there are like small mammal bones that are being preserved in the gut here, and I think probably bones of jerboas. Jerboas are this group of small hopping rodents. They're closely related to rats and mice, and they're found in like places like deserts of Afro-Eurasia. And yeah, they're a pretty interesting group, and they primarily move around by hopping. They have these really elongated hind limbs, and so yeah, it seems that this Miocene falcon was hunting these hopping rodents back during the Miocene, which is pretty cool. All right, do you have anything else to add to this?
Nope.
Alrighty then. Then we can probably move on to the next slide. In terms of the fossil record of crown falcons, as you can see, we actually have a pretty good amount of information. All of those fossil falcons that we just talked about, they're members of the crown group of falcons, so they belong within kind of the modern radiation of falcons. But when it comes to earlier species of falcons, or stem falcons, we don't have quite as much. It's actually a pretty big mystery kind of gap down here. So probably a big reason for that is that from the Miocene onward was when habitats started becoming more open, and probably it was during this time that we started getting this really big diversification of falcons, and so they started becoming more abundant and more diverse, and we start finding them more commonly in the fossil record. But before that, maybe they weren't quite as diverse, and maybe it would have been harder for us to recognize them as falcons, and so we don't have nearly as much information about their earlier evolutionary history. But we do have this one species from the Eocene of Germany that might provide us with some clues as to what the ancestral falcon was like. And this is a Messelasturids. Now, this is yet another bird from the Messel Formation of Germany. So, yeah, it is known from a couple of specimens. There's this essentially complete skeleton that you see here, and there's also another specimen with a better preserved skull. So this is not a huge bird. It's a pretty small bird for a raptor, like let's say pigeon size or so, maybe even smaller than that. And interesting enough, it does seem to be a raptorial bird because it has this hooked beak. However, the talons on its feet, which you can probably make out here, are quite small, and that's probably actually the reason it's called a parvunguis, which means small claws or talons, basically. So yeah, that's kind of unusual. Definitely don't really expect to see that in a raptor usually. But yeah, again, it does seem to be a carnivore though, and we're not entirely sure phylogenetically where it belongs. But out of all the living raptor groups, it does seem to share the most similarities with falcons, especially features of the skull and the feet. Do seem to be quite falcon-like, so perhaps this is a stem falcon, and if that's the case, this is probably our best represented example of a stem falcon. But even so, it would be nice to learn more. I did mention a few that Antarctic possible stem falcon earlier, also from the Eocene. That one is only known from a partial foot, and it's a bigger animal than Messelasturids. It's about the size of some of the modern caracaras. But yeah, other than that, not too much information that we have. There are also some possible falcon fossils from the Eocene of the UK. But yeah, pretty fragmentary stuff. Not much we can say about those. So yeah, the early fossil record of falcons is still very much a mystery. Um, all right. Anything to add about falcons before we go to the parrots?
No, I think that was a pretty good introduction. I mean, they're certainly very amazing birds that are they kind of blow away expectations when you look beyond the peregrine, as you mentioned before. And
Mm-hmm.
I think like this definitely demonstrates that.
Oh, good. Yeah, I agree for sure. Alrighty then. We will then continue on to the parrots, very unexpected cousins of falcons. Um, but yeah, they are certainly a rather different group. Parrots are known from over 300 living species, approaching 400, and with depending on how you split the species, maybe eventually we'll actually get over 400 species. Um, and so yeah, they are a very successful group as well. Now they are known from pretty much every continent in the world except for Antarctica. Um, but they're mostly restricted to the warmer parts of the world, so they prefer warm climates. Um, and in the modern day, they are not found as natives to Europe. However, they are present in Europe as introduced species, and in fact, over here in the UK, there are rose-ringed parakeets that can be found in some of the city parks around here, especially near London. Um, and yeah, those are introduced species that have managed to take a foothold here. Um, and yeah, rather unexpected, that's for sure. You don't really expect to see parrots in the middle of England, but there they are. And in fact, they actually these introduced parrots actually cause some trouble in parts of Europe. Um,
Mm.
so, for example, in Spain, I know the rose-ringed parakeet has also been introduced there. So that's a species that is natively found in southern Asia and also Africa. Um, but introduced to Europe, something kind of troublesome to the local ecosystem that they do is that they compete with some local species like bats for roosting sites. So parrots like to nest in tree hollows. Um, and well, bats also like to live in tree hollows, or at least some species of bats do. And the problem is that, well, the parrots that have been introduced into Europe, they will often attack and kill bats that they find in tree hollows because they don't want to share. And so, yeah, parrots, one of their most notable features is that they have this really powerful hooked beak, which is very useful for feeding on fruits and seeds, but it is also uh, quite a dangerous weapon that they can use against animals that are around the same size as them or smaller. And so yeah, these bats that compete with them for tree holes don't really stand a chance and are killed by them. Um, so yeah, that's the kind of troublesome thing that that parrots get up to when they are introduced to places where they don't belong. Um, but yeah, in the fossil record, however, as we shall see, we actually did once have European parrots, but yeah, we'll get to those later. Otherwise, parrots can be found in the tropics of yeah, pretty much all the other continents: Africa, Asia, Australia, and the Americas. And as already mentioned, they have a very powerful hooked beak that they can use for all kinds of interesting things, not just killing bats, but also for manipulating objects. Um, so in parrots, the joint at the base of the upper beak is extremely mobile. So we talked about before how modern birds have this joint at the base of the upper bill that can flex the upper jaw up and down independently of the rest of the skull, which is a pretty unusual feature. Definitely not many other vertebrates can do this. But in parrots, they kind of take the mobility of this joint to a real extreme. And there's a very well known video posted by Larry Whitmer. He's a paleontologist, but he also studies modern animals a lot, especially kind of soft tissue features and biomechanics and things like that. And so he posted a video on the YouTube channel for his a lab, and where he manipulates a parrot skull, and he is able to basically like flex the upper jaw of that skull to a ridiculous degree without breaking it. And now, to be fair, the kind of dried out skull probably has a more mobility to it than a living skull, but nonetheless, it kind of shows how mobile this and well developed this joint at the base of the upper beak is in parrots. And so, because of this, parrots can use the beak for all kinds of like fine manipulation. They can pick up objects and kind of move them around within their beak and kind of use tools, for example. We'll talk about a bit more about that later. And also, they use the beak for climbing as well as sort of essentially a third foot, essentially. So parrots are very good at climbing. They're mostly tree-dwelling birds, after all. So they'll climb using not only their feet, but they'll also use their beak as a sort of hook to kind of make their way up tree trunks and other vertical surfaces. So yeah, the beak is a really handy tool for a parrot. And of course, one of its main uses is for feeding, and so they can use a very powerful beak. They have an amazing bite force, and with that big hook at the end, they can crush very hard fruits and seeds. With it, most parrots feed a lot on fruits and seeds. However, there are some that specialize in feeding on a very different kind of food, and that is nectar, which is a food that doesn't require any kind of crushing at all. But well, there they go, I guess. And the way that they feed on nectar is quite interesting because, of course, this really hooked bill is not ideal for extracting nectar from a flower. But parrots also do have this very mobile tongue, and so a lot of the nectar feeding parrots, their tongues have this have evolved to become very brush-like. They have this brush-like tip with all these very these dense bristles kind of covering the tongue, and they'll use the tongue to soak up nectar and then extract it from flowers, and so that's how they feed on nectar. Famously, the lorikeets of Australasia are a group of nectar-feeding parrots, and in a lot of zoos, I know that they'll actually give you the opportunity to feed lorikeets by giving you cups of nectar or at least sugar water, and you can just walk into this aviary with a bunch of lorikeets, and they'll land on you or beside you and take the nectar from the cup, and you can see how they use their tongue when they do that. That's pretty neat. Um, have you ever been to one of those exhibits?
Oh yeah, of course. Uh, uh, um, Sylvan Heights
Yeah,
was probably the best version of that I've been to. 'Cause I've seen them in all kinds of different zoos,
right.
but either we never really took the time to go and do it, or when we did try to do it, the birds just kind of kept to themselves. But in this particular case, like they were very welcoming. Um, they would fly all over you, and they would land on your shoulders or your arms, and it was there's very specific instructions. when going into those places. You don't want to be too rough with the
Of
birds,
course, yeah.
obviously. So you kind of have to hold it out to a certain extent, and like they'll land on the little toothpick or popsicle stick, and they'll eat the seeds. Sometimes they'll go on your hands and eat from there. But occasionally, like if you have like a hair on your arm or whatever, like they'll get curious and start nipping at you, and all you got to do is just take your palm flat, put it on the upper part of your arm, and just kind of lightly brush,
Mm.
and the birds take the hint and then they fly off and either go somewhere else on your body or they just kind of fly away.
Right,
But
right.
oh, it's really fun. Because I've never had a pet bird
Mhm,
before,
mm.
and that's probably the closest I think I'd get to experiencing something of that nature. Just
Right.
having a bird hang out with you on your body, like like a pirate or
Yeah,
something.
right, right.
Of course, our good friends Meg and Max, they have um, pet parrots,
Yep.
and
Mm.
and it's kind of I got to meet them during one of my trip to Chicago, and they it's kind of a similar experience. They're
Yeah.
very fun. They're very chipper, noisy birds, and
Mm-hmm.
they're cute.
Definitely, yeah.
A lot of personality.
Yeah, definitely. Parrots can be quite interesting companions. That's for sure. I'll comment a bit more on like kind of relationships between parrots and people a bit later. But yeah, certainly they can be quite an interesting source of companionship. Um, Now, continuing with kind of notable parrot features. They also have a zygodactyl feet. So we've spoken about this quite a number of times already, but a zygodactyl foot is this particular term referring to bird feet that have two toes pointing backwards, the innermost and the outermost toes. So in most living birds, it's only the innermost toe that points backward. But in parrots, there are two toes pointing backwards. And we also talked about this before, but this is probably a foot that is particularly specialized for grasping perches and such. And so that's certainly very helpful for a tree dwelling bird. Um, Furthermore, in parrots, they can also use the foot as a kind of tools for manipulation. So they'll grasp objects with the foot, and in fact, they have a very distinctive way of feeding. A lot of time is that they'll actually hold a food item in one of their feet, and then kind of pick at it with their beak, hold it up to their beak to feed on in that posture. So yeah, that's a pretty interesting feature that they have. And as also mentioned before, probably the evolution of a zygodactyl foot and a lot of these other weird toe arrangements depends on having a kind of protracted period of development where the babies are kind of spend a lot of time rather helpless. And so this basically allows them during the embryonic stage to have a longer period of time where the orientations of the toes can be influenced by kind of muscular actions in the foot. Um, so yeah, that's quite interesting, and certainly parrots do have a very protracted period of development, and it can take them months or even years for them to reach maturity, which is pretty unusual for a modern bird. In most modern birds, they grow incredibly fast, like in a matter of weeks. But certainly, this protracted period of development probably helps a lot with gaining notable cognitive and social skills. And as we shall
Mm.
see, those are very important skills to parrots. Now, kind of related to that is parrots exhibit an ability called vocal learning, and so that's an interesting ability that they share with us actually. So vocal learning is the ability to learn different sounds and repeat those sounds back. And that's of course how we learn to speak. And it certainly is something that parrots can do, and they're rather famous for it. They can learn all kinds of different sounds, and they can mimic speech of humans, for example. And yeah, they are one of the few groups of birds that are capable of vocal learning. So, one of the other groups of birds that can do this are the songbirds, which we'll meet in the next episode, and also the hummingbirds as well, also have vocal learning. So, a lot of the calls that parrots make are not instinctive, they are actually learned from other members of the group. And so, that's also a big part of, you know, well, what they have to learn while they're growing up. Um, it's rather interesting looking at all these different aspects of parrot biology, because it turns out that they actually share a lot of parallels with uh, a certain group that is very familiar to us. And that, of course, is the primates. Of course, we are primates too. And yeah, the
Mhm.
parrots and primates have a lot of interesting convergent features. I mean, just look at all of the ones that we've already talked about here. So, parrots are very good at manipulating objects, in this case, using their beak and their feet, whereas primates tend to use their hands. But in any case, it's a similar idea. Um, Parrots specialize in feeding on fruits, especially, and certainly a lot of primates also feed a lot on fruits. Um, and parrots have this really protracted period of development where they have to learn a lot of social and cognitive skills, and it's exactly the same with us. We also have a very long childhoods where we have to learn a lot of different social and cognitive skills as well. And of course, there's the vocal learning, which helps with the communication aspect of things. And so, in a lot of ways, parrots are probably the closest parallels we have among birds, or probably among all reptiles for that matter. So it's kind of funny because of course people love to speculate about, oh, what if dinosaurs evolved into human-like forms in some kind of alternative timeline? And well, they kind of actually did, if not human-like, then some of the deadly primate-like forms. They kind of already did because we have parrots, and parrots are very primate-like in many ways. Um, and certainly the parallels don't really end there, but I'll go into more detail about that on a later slide. But before we go into more about parrot evolution, do you have anything to add about parrots?
Um, I guess as far as like thinking about like life experiences with
Mm-hmm.
parrots, I think it's safe to say like the mostly tropical to semi-tropical distribution of these birds means that I haven't really had any wild experiences with them in my
Yeah.
lifetime. Um, Not this last trip to Florida, but I have gone to previous trips where I've seen introduced
Mm.
parrots
Yeah.
there, flying around in like coastal cities, that sort of thing. It's sort of a similar thing with you in to what's going on in Europe.
Yeah.
Of course, North America, well, northern North America used to have a very common parrot
That's right.
species, the Carolina parakeet,
Mm-hmm.
which is a very very beautiful bird that it's green. It has kind of like it's got a green body. It's got a yellow neck
Mm.
and a red head. So
Right.
it's kind of got a nice little rainbow thing going on there. Sometimes they have like blue on the tips of the wings,
Yeah.
but they used to be all over the place in the eastern half of North America. I think they kind of extended a little bit into the the Great Plains a bit,
Yeah.
but and what's interesting too is that it would be like wintertime and there'd be snow on the ground and
Right.
there'd be straight up colorful parrots outside foraging,
Yeah, exactly.
which is just an amazing thing to think about.
Mm-hmm.
And they tended to be seen and mostly in like the forests, sometimes on in coast in freshwater areas, rivers and lakes, that sort of thing. So
Yeah.
it makes sense, for a parrot. Um, but yeah, they were common across eastern North America for a time. Of course, they were described by European settlers and illustrated, perhaps famously by Audubon.
Mm-hmm. Yep.
I actually have a little picture in my room that of his Carolina parakeet prints.
Mm.
Um, but it turns out that there was, of course, as you might expect, issues with subsequent history of the Americas
Right.
involving Europeans, and like there's a lot of deforestation that had gone on in the eastern part of North America. There were concerns about croplands, and because these birds would, go after certain crop plants
Yep.
that people were planting, and of course there was also aesthetic purposes
Yeah.
that aesthetic reasons that people would go after these birds, cause all these colorful feathers. It's kind of nice to have as part of clothes or whatever.
Mm-hmm.
And so by about the early 20th century.
Mm-hmm.
I think if I look correctly, it's about 1918. They had all been wiped out.
Yeah,
I think the last one actually died in captivity. It was it was living in the same cage that the last passenger pigeon had lived in,
that's right.
Martha, who we talked about earlier. So that's kind of a an interesting detail. But yeah, that was our native Northern American parrot for the
Right,
longest time. And since then, of course, there have been escaped and released birds
right.
from more domestic settings, and so now like there are like parrots roaming around in North America again, but they're all from they're all introduced species from outside the continent.
That's right.
Sometimes they're like there's budgies from Australia, and then
Right,
there's various South American forms. You open up any like comprehensive bird field guide, and there's a whole page of just introduced parrots.
right, right.
So it kind of gives you like the scale of this sort of thing. But yeah, I have not seen any others of those besides my trips to Florida.
Mm, yeah,
I think like the pop culture presence of parrots is
right.
more I'm more familiar with than say like seeing them out in the wild because
Yeah,
parrots
definitely.
are so charismatic, and I think most folks like parrots, so
Hmm.
that they've had a pretty healthy range in human culture and society throughout time.
Yeah, definitely, definitely. Yeah, I would say like yeah, most of my experiences with like wild parrots are also like with the introduced species around here. But um, when I visited Australia, I definitely saw some native parrots there, and quite commonly as well. Yeah, like yeah, you got like rainbow lorikeets and sulfur crested cockatoos just in the city parks and stuff. That was really cool. Um, so
Yeah.
definitely saw quite a few species there. But yeah, otherwise I haven't had too much experience with wild parrots either. And yeah, mostly know them from captivity and popular culture, definitely.
Oh yeah, I mean zoos. I mean like what zoo doesn't have a parrot of some
Right,
species,
right.
right? It's like it's almost that's almost like a staple. Like you're gonna
Yeah,
open a zoo, you gotta have parrots.
right, right. Alrighty. Well, on the next slide, we'll get to know the diversity of parrots a little better. So this is a phylogeny of the living parrots. Um, and so you can see how they're divided up into several different groups. Um, so the group that is kind of outside of the remaining parrots are the New Zealand parrots, so known from three living species. Um, so the one pictured here is a pretty famous species called the kakapo, and it is
Mm.
a quite a special and distinctive bird for several reasons. So first of all, it is the largest living parrot. Um, so yeah, it's about like chicken size or so, and it is also the only essentially flightless parrot. Um, so that is also quite interesting. It does still have fairly decently sized wings, which it can sort of still use in a to assist with locomotion in some ways. So sometimes it'll like jump out from trees, for example, and then it'll try to flap its wings to kind of break its fall and things like that. And it'll also use the wings for balance as it climbs up trees and things. So yeah, it's still a very good tree climber, even though it can't really fly. Um, and in fact, quite memorably, the in the classic book, A Last Chance to See by Douglas Adams, where he describes his experience meeting Kakapo, um, he mentions something like the thing about the Kakapo is not just that it has forgotten to fly, but also that it has forgotten that it has forgotten how to fly, which was referring to the fact that they do the kind of jumping out of trees thing. Yeah, so that's a pretty funny passage. Um, but yeah, so they do still use the wings for a few things, but yeah, not it's essentially flightless, you could say. Um, and furthermore, it is also one of the few nocturnal parrots in the world. So yeah, and it is extremely endangered. In fact, it was thought to be pretty much wiped out. But fortunately, there are very intense kind of conservation efforts ongoing um, to
Right.
to keep it alive. And so basically all the world's, well, it's only found in New Zealand, but basically all the kakapo in the world have been kind of transferred to smaller islands offshore of the two main islands of New Zealand, and basically heavily monitored. Like every single individual is tracked, and basically breeding is encouraged. And being on those islands basically keeps them safe from introduced predators that have been, brought to New Zealand. Things like cats and rats and weasels. And so yeah, they are heavily monitored. You can follow. There's quite a bit of a social media presence for the Kakapo recovery program, so you can follow kind of their progress on the internet, and help out with donations if you can. But yeah, it's certainly a very very special bird, and it would be a shame to lose it. So far, the conservation efforts have been quite successful, by which I mean there are currently over 200 adult birds around at present, which of course is not a lot, but is a dramatic success compared to their essentially depleted population before. So hopefully they can keep
Really,
momentum going. Yeah,
they look cuddly,
they do.
which I imagine certainly helps with the push for getting the word out about their conservation.
That's right.
I'm hard pressed to find people who know that there are like flightless parrots in New Zealand.
Oh
So
yeah.
could be a little bit better. But yeah, the conservation story behind these birds is really interesting. Like when Albert mentions like they're all monitored, like each one has a name.
Right.
Like that's how close like these birds are being cared for, which is just amazing work.
Yeah. Yeah, like kind of the trick with Kakapo, I guess, which is you know true of many parrots, but it's especially pronounced in this species probably because it lived for so long on an island where there wasn't as much predation pressures, that their reproductive cycle takes a really long time. And I think they essentially mostly breed in ears where food is abundant, basically, and because they're very long-lived birds under their kind of natural circumstances, that works out well for them. But it doesn't work out as well if they are getting killed by in huge numbers by introduced predators, and so that was a really big kind of threat to them. And so there definitely are efforts underway, not just in breeding kakapo, but also kind of removing introduced predators from New Zealand. Hopefully, those efforts go well. Yeah. So yeah, really really distinctive bird for sure. Now there are a few other species of New Zealand parrots. Another one is called the kaka. Um, and another one is called the kia. So those together are the three different species of New Zealand parrots, and the kaka and the kia are a little bit more typical kind of parrots. They are flight capable. They are also of a kind of conservation concern, but they're not quite as endangered as the kakapo. And the Kia, in fact, is a rather quite an adaptable bird. In its relatively recent history, has started to move up into alpine habitats, up into the mountains, like even the snow, and probably to avoid people. So yeah, that's quite interesting. So it is sometimes called the world's only alpine parrot, but that actually has recently been found to be a rather recent kind of thing in its history. So basically, researchers have compared genome sequences from the kaka and the kia, and they found that the Kia genome doesn't really contain any kind of signatures of like specific adaptations to mountain environments, and so they suggested that yeah, actually, it did not start out kind of specialized for alpine environments. It kind of probably moved up in there to after humans arrived on New Zealand. So yeah, that's quite interesting. But they seem to be doing reasonably well considering that. And sometimes, in fact, they can actually cause some trouble for people because like Like all parrots, Kia is a very curious kind of bird. They like to explore things, and by exploring, I mean like manipulating things with their beaks and potentially destroying them. And so, yeah, they are rather infamous in some parts of New Zealand, where they'll kind of rip off windshield wipers from cars and things like that. So yeah, they can be a bit troublesome. Um, but because they're also endangered, so they people also they are also protected, and yeah, like there can be a bit of conflict there. I know there was something I saw a while ago on the news where I think people were setting up like basically play areas for the Kia, like
Oh,
they'll set up like little playgrounds of with things that the Kia could explore, and hopefully the intention was that hopefully those would distract them from like you know doing that to objects that people care about, like cars. Yeah, I don't know how well that program is going, but it certainly is a really interesting idea. Um, yeah, that's pretty cool.
oh, definitely. I was gonna ask because
Yeah.
I this is something I used to read about all the time whenever like Kia came up.
Hmm.
Is it true that they'll kind of like pick on sheep?
Uh, yeah, I was going to mention that next. So yes,
Oh,
that is a very unusual behavior that Kia have. Um, um, Yes, so they will actually eat sheep, and so the way they do this is that yeah they'll come in often at night. They'll come in and land on top of like sheep and live sheep, and then they'll just bite chunks of fat off the sheep.
oh,
And I suppose it's extra protein and all that. But yeah, definitely it's a partially carnivorous parrot, which is fairly unusual. I mean, a lot of parrots will though they're not super picky, so like if you give them a bit of meat, they'll probably eat it. You can probably find a lot of videos of like pet parrots eating chicken and stuff like that, and people freaking out for the reason that we mentioned earlier. Um, but yeah, like the Kia will habitually like go after sheep and take chunks out of them, which usually doesn't directly kill a sheep, but as you might imagine, it can, you know, cause problems uh, and down the road for those sheep, and so obviously people don't really like it when that happens. Um, so yeah, it is true. It was thought to be just like anecdotal for a long time, but like eventually people would start putting up cameras at night to film what was going on,
hmm.
and yeah, it is true. They actually do it. So that is well goes to show how quick they are to take advantage of a new resource. Because of course, sheep are not native animals to New Zealand. Um, it has been suggested that perhaps in the distant past, well, maybe not so distant in the grand scheme of things, in the past, Kia once did this to some of the large birds of New Zealand, things like the moa, for example. Maybe
Huh.
they were biting pieces out of moa. Who knows? It does seem possible. Like if they can figure out how to do it with a sheep, then maybe it's something they once did with other animals. Um, so yeah, quite an unusual species. Um, and then with the kaka, that's a less well known animal. It doesn't really hang out with humans as much, near humans as much. But it is very similar to the Kia overall in terms of its appearance. It also has a very sharply hooked bill. Slightly different in color though. It's a little bit more brightly colored with like kind of splashes of orange and stuff. And certainly another very distinctive New Zealand parrot that it would be a shame to lose. So it is a good thing that people are paying close attention to the conservation of all these species. All right, the next group of parrots I have pictured on here are the cockatoos, and this is probably a group that many people have heard of. So this is a very distinctive group of parrots with this nice crest on top of their heads, which they can kind of raise or lower as they need to. Usually, when they're more excited or agitated, they'll raise the crest up, as can be seen in the picture here. This is a sulfur crested cockatoo, one of the best known species. In terms of their native habitats, the cockatoos are primarily known from Australasia. So, yeah, they're kind of restricted to that region of the world. And yeah, like I said earlier, when I visited Australia, I saw quite a few different species of cockatoos, and sometimes they could just be found hanging out in city parks. So yeah, that was definitely really cool. And then all the remaining parrots of the world can be split into two main groups, and quite conveniently, they roughly correspond to their geographic distribution, but not exactly. So one group is a group that I hear called the American parrots. Um, and so these include all the parrots that live in the neotropics, but they also include a handful of African species as well. So they include things like the African gray parrot, which is probably the best known of the African contingent of this group. So yeah, there's roughly around, I think, a dozen or so African species in the American parrot group. But by and large, the majority of their diversity is found in the Americas. And then we have the Afro-Eurasian parrots, which include most of the species living in Africa and also tropical parts of Asia. And they are also actually still quite diverse in Australia as well. So I guess Afro-Eurasian doesn't quite cover their entire range, but it does distinguish them from the American parrots. Um, I guess I might as well mention this. So it was kind of a conscious decision here to use the terms American and Afro-Eurasian instead of Old and New World. I know in the previous episodes I have used a New World and Old World to refer to geographic distributions, and it is still very common in biogeography. Um, but I do know that these terms are sometimes depreciated because of kind of the colonialist and Eurocentric
Mm.
aspects of them. And so I'm kind of considering switching to using the terms American and Afro-Eurasian instead, which I think work pretty much just as well. So yeah, that's the reason for that. um, but yeah, in any case, the American parrots and the Afro-Eurasian parrots certainly represent the majority of parrot species, and I guess together you could consider them to be like the core parrots or the typical parrots. And yeah, they are pretty much the parrots you think of when you typically think of parrots. They're brightly colored and highly intelligent, very social, and all of that. Um, and yeah, um, so do you have anything to add about parrot diversity before we move on?
I mean, yeah, just kind of certainly reiterate that. I mean, like for being such a large group of birds, like very diverse body forms. I mean, you have things like the little budgies and lorikeets,
Mm-hmm,
and
yeah.
one of my favorite parrots are the hanging parrots,
Yeah.
or
Yeah.
Unus loriculus, which is, oh, how do I describe them? So, like they're like typical parrots, like in pretty much like body shape and like what they do, like they eat fruits and seeds
Yeah.
and
Yeah.
stuff. But they will often kind of hang upside down
That's right.
off of branches, and it looks so funny to me.
Yes.
And I've always like thought of that, like whenever I look at like the diversity of parrots. And of course, they have like much larger things like macaws
Mm-hmm.
and the Amazons, which are very heavy bodied. Um, of course, I'm very familiar with Amazons because the Disney character that I quite like is Jose Carioca.
Oh yeah, that's right.
He's a Brazilian parrot from one of the early package films back in the 40s, Saludos Amigos, which I actually rewatched recently
Oh
because
cool.
me and my folks, we were watching one of the behind the scenes documentaries called Walty El Grupo about his trip to South America as part of the Goodwill program. And yeah, like in the film, there's like an Amazon parrot sitting on a drawer's desk, and it's like, oh, with a little imagination, we can make a brand new personality. That's how they made the character. I couldn't tell you what species it was
Mm.
though, but I'm sure I could figure it out. Apparently, it's like one of Brazil's like most famous parrots in like pop culture. It's
Mm.
like the one that shows up in like uh, seals and stuff, that sort of
Right.
thing.
Right.
Um, but yeah, and of course macaws. I mean, I think macaws are the largest of the parrots, if I'm not mistaken, in terms
Yeah.
of.
Other than the kakapo, yeah, the macaws are the next largest. Yeah. Mm.
And of course, like they're I feel like they're usually like the kinds of parrots that you see in pop culture
Mm-hmm.
nowadays.
Right.
Just very iconic. They're high flyers. If you go to a zoo, if you're lucky, they'll do like free fly shows
Oh
where
yeah.
they have a bunch of trained macaws, and they
Mm.
just like, okay, go over there, and then they fly over the audience. Whee!
Right.
It's
Right.
it's
Right.
so cool. Just amazing birds. Of course, for those of you who are interested in animation history, I'm sure you're familiar with the Rio films.
Mm. Yes. Mm.
And the, the Spix macaw
That's
is
right.
the star of those films, which is a real species.
Mm-hmm.
I've never heard them called blue macaws,
Yeah,
but
not
I mean that's
yeah.
pretty much what they're like a indigo blue. But they're really fascinating birds, and they are like heavily endangered.
Yeah,
Not I don't think in the sense of like the movies are, where like they had just one in captivity and then
right.
another one, and then they gotta breed them together to save the species. But last I checked, I think they have like been declared extinct in the wild
That's right.
now,
Yeah.
at the very, which is the real shame. Um, but they are still around, and there's a concerned effort to get those numbers back up and running.
Right, right. Yeah, definitely.
Um, but yeah, just certainly a lot I could say about different parrot groups. Just a wonderful collection of
Oh
birds.
yeah, 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 yeah. I kind of glossed over it, but yes, the diversity in kind of their body sizes and forms is quite incredible. And yes, the hanging parrots are definitely delightful. I think they even sleep upside down, so that's
That makes sense.
yeah, yeah. It's pretty cool. And yeah, if you're not familiar with them, they're one of the smaller species of parrots too. So they're just like little brightly colored puffballs basically. And I've seen them in zoos. The National Zoo in D.C. used to have them in their birdhouse, and yeah, I have seen them doing the upside down thing. So yeah, they are funny and very cute. All right. So, something interesting about parrots, if you're looking across this phylogeny and how they're kind of essentially divided by geography, is that it is thought probably parrots originated in Australia, modern parrots at least, um, and this is based in large part on the kind of distribution that we see here. Um, and so we have, for example, the New Zealand parrots being the sister to the rest. And well, New Zealand essentially, we kind of talked about this in the Paleonate episode, but there is this classic idea that New Zealand is a kind of lost world where everything there was unchanged and has been unchanged since the Mesozoic or whatever,
Hmm.
like for millions of years. It's just unchanged with everything having arrived there from splitting off from the rest of the southern continents. But in recent times, we started to it started to come to the realization that this probably isn't true. So probably most of the at least most of the vertebrate fauna of New Zealand are probably much more recent arrivals. Now, in some cases, they might have still arrived, say, over 15 million years ago, but it's not anywhere close to like during the Mesozoic, like 80 or
Right.
70 million years ago, like has often been claimed. So a lot of these vertebrate faunas that now live in New Zealand, a lot of them probably came from Australia originally. And so essentially, uh, New Zealand is kind of the spin-off place where things from Australia just get lost and get blown to by storms and such, and they start doing their own thing on New Zealand. So yeah, there was the classic paper I talked about doing the Paleonate episode, um, where it was said that yeah, maybe New Zealand is not so much a lost world and more like the flypaper of the Pacific, but that is still a very fascinating kind of evolutionary story. Um, and so probably the New Zealand parrots were one of these groups that made it over there from Australia originally. And of course, we have the cockatoos, which are a primarily Australian group. Um, and so it seems to make the most sense um, that originally the parrots, crown parrots at least, lived ancestrally in Australia before spreading out to other parts of the world. Um, and even today, the Afro-Eurasian parrots, for example, are still very diverse in Australia. So things like the lorikeets, for example, are members of the Afro-Eurasian parrots. Um, and so on the next slide, I show from a paper hypothesized kind of dispersal events within the parrots. So probably these dispersal events happened sometime during the Eocene, and when some of the southern continents were still somewhat closer together. So, for example, Australia and Antarctica were a lot closer together to each other, and there were some possible kind of island chains that extended off Australia and Antarctica. So you can see here the labeled Broken Ridge and the Kerguelen island chains. I'm not sure I'm saying that right, but in any case, probably a lot of these island chains were helpful for parrots for dispersing across the ocean, and so the authors of the study that this figure came from, they inferred that probably there were at least four separate dispersal events out of Australia among the parrots. So one of these would have been the bottommost arrow here. So those would be the American parrots heading to the Americas. And then the next arrow up are the African contingent of the American parrot lineage. So the ancestors of the African gray parrot and such heading to Africa. And then we have the ancestors of things like the lovebirds. They belong to the Afro-Eurasian parrot radiation, going also to Africa. And then the kind of last arrow up here on the top are some of the Asian parrots from within the Afro-Eurasian lineage, also heading upwards to Southeast Asia. And so, yeah, probably a number of these dispersal events out of Africa occurred within the parrot lineage to attain their current day kind of modern distributions. And so, yeah. And their origin in Australia is interesting and is going to come into play a little bit later. But do you have anything to add before we move on?
Not particularly, but this is a good diagram for sure.
Yeah, I quite like it. All right. So, all right then, let's talk about parrot intelligence. Then we'll take a little detour here, but this is a very notable aspect of parrot biology, is that they are widely considered to be among the most intelligent animals there are. Um, and so, we have mentioned before on this show about how defining intelligence is really difficult. Like, well, what does it really mean to say an animal is smarter than another animal? Um,
Yeah.
and yeah, I think there's definitely a lot of truth to that. I think that ambiguity, um, it's it is very difficult to kind of compare intelligence between different species, because I mean, for one thing, some animals that are really good at some kind of skill can be really bad at another one, and vice versa. Um, and so it is it is a bit kind of nebulous, I guess, to talk about what is the smartest animal, or what are the smartest animals. Oftentimes when people talk about what an intelligent animal is, they just mean that, oh, this animal has very similar kind of mental skills to humans, and that's kind of what I mean. We use ourselves as a definition for what intelligence is. And so, yeah, I think those are the caveats that are worth keeping in mind. Um, but nonetheless, I think it is fair to say that parrots are good at a lot of things that would lead us to consider them to be highly intelligent. And I know, at least based on what I've read, a common definition of intelligence used by animal behaviorists, people who study animal behavior, is the ability to flexibly solve problems using cognition instead of instinct or trial and error. And this is a definition I got from a blog by Kaylee Swift, who studies the behavior of crows and ravens and their relatives, the corvids, which are another group of very intelligent animals, or at least widely considered very intelligent animals. And so this is a definition that she gave on her blog when she talks about what intelligence is. And so I think it's a fairly reasonable definition for what we tend to mean when we talk about intelligence. So yeah, the ability to kind of solve problems in your head, and not just being able to perform complex behaviors by instinct, which certainly a lot of animals can do, and it's still very impressive. Or simply just kind of hitting upon the solution by trial and error. So I think that's probably not a bad definition of intelligence. But Kaylee Swift does caution that yeah, it can be really misleading to talk about what does it mean for an animal to be more intelligent than another animal. So she kind of does say that she's not fond of like ranking animals by intelligence. Like, oh, is a raven smarter than a chimpanzee, or you because animals can be good at very different things, even on a cognitive level. They can have very different kind of cognitive skills, even if they're both considered to be highly intelligent. Um, so yeah, I guess it is interesting to study the cognitive abilities of animals, um, but it but maybe we shouldn't focus so much on which animals are smarter than other animals and more on just what are these specific animals capable of, and why are they capable of those things? Like what kind of evolutionary pressures led them to that point?
Hmm.
Um, yeah, but in any case, it is true that parrots do exhibit a lot of different skills that we would consider to be signs of intelligence. And I provide an incomplete list here. There have been a lot of different studies done on this subject, and there have been a lot of different skills that we have found out that parrots are capable of. But here are just a few of, I guess, I think my favorite examples, and also some examples I think are especially notable. I will stress that not all of these skills have been found in all types of parrots, and in fact, we do know for some of these that there is variation in the performance of different species of parrots. Um,
Hmm.
but nonetheless, the fact that we can find all of these different skills in this group of birds does strongly suggest that they are very cognitively complex in general. All right. So, yeah, do you have anything to add before we go into this list?
Um, Not particularly, but I definitely think that uh, that definition is pretty fair, considering that. I mean, yeah, like a lot of discussions about animal intelligence are usually given like a human baseline,
Right.
and like it's not really a competition like that.
Right, exactly. All right then. So yeah, let's talk about some examples of this highly complex cognition in parrots. So of course, one of the most famous examples and one of my personal favorite examples is Alex the parrot, or the studies
Mm.
that centered around him. Um, and so Alex was an African gray parrot, and so I've pictured here on the top left a classic book documenting a lot of research that was done on him. Um, so Alex the African gray parrot was bought from a pet store in the 1970s by Dr. Irene Pepperberg, who is an animal psychologist. Um, and she named him after her research project, which was avian learning experiment, hence Alex.
Oh.
Um, and so what she did was that she trained Alex to learn specific words, the spoken words, as labels for objects and their attributes. So he could identify specific objects and label them by the correct word for that object. Um, and then she could then ask him about to identify specific aspects of those objects. Like she could hold up two different colored objects and ask him what's different, and he would say color. The color is different, and he could do that with like shapes and textures and such. Um, and so yeah, that was a definitely really really impressive, and these were like groundbreaking studies that just showed people what parrots were capable of. And one of the, I think, most impressive and surprising results that came from these studies was that Dr. Pepperberg found that Alex was capable of inferential reasoning. So basically, he learned to label like Arabic numbers by the words corresponding to those numbers. So you could show him like the number one, and he could label that as one, and all the way up to eight prior to his death. Yeah, he had made it all the way up to eight, but he could also label like amounts by the same words. Yeah, he could be shown like a collection of say four objects, and then if they asked him what number, he could say four objects. Um, So he was trained to, recognize amounts and recognize Arabic numbers separately, so associating them with those words separately. But then he was also able to draw the connection that, oh, so the Arabic numbers have equivalents to the amounts as well, not just to the words. And so they could show him an Arabic number and a certain amount of something, and then he would be able to, he could answer correctly questions about which number was bigger, even though one was an Arabic number and one was represented by an amount. So yeah, that's inferential reasoning, that A equals B and B equals C, so A and C are also equal concepts. And yeah, he was able to figure that out. Really impressive. And naturally, there was, of course, some skepticism about these findings. People have been very wary of these types of animal research into animal cognition, especially due to the example of the horse named Clever Hans. And there's a name that's given to the phenomenon. It's represented by that, called the Clever Hans effect. Basically, this horse was said to be capable of doing math, like it would tap out numbers of beats on his hoof, using his hoof, based on the questions he was asked. But it was found that he was essentially being cued by his trainer, or unconsciously. Like he would pick up on subtle body language and then be able to stop tapping at the appropriate time to answer these quote unquote questions correctly. And so, of course, there has been some skepticism of, oh, well, what if this was what was happening with Alex? But this seems rather unlikely, because first of all, he wasn't only able to do these exercises with Dr. Pepperberg, with just one specific person, but with anyone, just about even complete strangers were able to ask him questions and get correct answers out of him. And furthermore, he showed signs of being able to put together novel concepts based on what he had learned. For example, he apparently once he did know the word for apple, for example. So once when he saw an apple, he called it by the name banary, a word that he made up, banary. And it is suspected that he probably called it that because it reminded him of two different fruits for which he already knew the words for, bananas and cherries. So the apple probably tasted to him a little bit like a banana, and it looked a bit like a big cherry, right? They're red and round.
Yeah.
So yeah, he made up a label for the apple based on that, perhaps. And there are also times when he seemingly didn't feel very cooperative, and he would get questions wrong on purpose. Like, yeah. In fact, some of his successors, the other parrots at the Dr. Pepperberg's lab still studies, have been known to exhibit the very similar behaviors. Like I once read an anecdote about a different parrot named Griffin, where he was asked what number is this, and then he would answer every number he knew except the correct one. And if he was just shouting random words randomly, you wouldn't expect him to only answer by numbers, right? They knew a lot of words. They knew about colors, they knew about shapes, but only the numbers. So I think these studies provide very strong evidence of at these very complex cognitive abilities in African gray parrots. Now, unfortunately, as I mentioned kind of earlier, Alex has passed away. He passed away in 2007, and very unexpectedly, well before the expected kind of life, expectancy for an African gray parrot. He was only in his 30s or so, and their average kind of lifespan is in their 40s. And he showed no signs of poor health beforehand, but he just died very suddenly one day. And yeah, which was very unfortunate. However, Dr. Pepperberg's lab is still studying other parrots, like I mentioned earlier, and still uncovering kind of new discoveries about their abilities. I think something important to mention is that Dr. Pepperberg has been very clear that her goal was never to teach parrots language. They're not really they're not really using a language in the sense that a linguist would consider to be language. Like they're not using like say syntax, for example. Like they're not using
Mm.
like complete sentences to converse with people or things like that. Like the reason that Dr. Pepperberg is doing this research, that the reason she taught these parrots to speak these words is not to teach was not to teach them language, but to give her a way to be able to study the cognitive abilities of these parrots by being able to directly ask them questions and such. So that's a reason for teaching them these words in her research project. It's not to teach them to use language, but that really doesn't take away from the fact that she's found some really amazing things with this method, and these studies are still continuing. So Alex has left a really strong legacy, I think. Um, do you have anything to add about Alex the parrot or the related research?
No, I definitely agree. Like his contributions were so important. Um, Definitely, I remember. Like I even learned about Alex through like primatology context,
Yeah.
because of the similarities there. Um, yeah, just a fascinating individual, and I don't mean to bring the show down a bit, but I'll never forget because like this used to get shared around a lot on social media, and I've since been able to confirm it. So it's not one of those things that's like not technically true. But apparently, his last words before it found out that he passed
Mm-hmm.
were this. Of course, after every I guess session,
Yeah.
when Dr. Pepperberg would do these things, he would say like the same thing to her on her way out, which I guess was like, you have a good day, I love
Yeah.
you,
Yeah.
or
That's right.
something along those lines. And like
Right.
he said that like the day before he passed, and
Yeah.
just that
Yeah.
just gets you.
Yeah. It is. It is really sad. And I know Dr. Pepperberg has written a memoir based on her experiences with Alex following his death. So it's called Alex and Me, I believe. I haven't read it myself yet, but yeah, I think that would be a good good place to learn more about these studies and the history of Alex.
Definitely,
Um,
we'll be sure to put links to that book as well as the Alex studies in
sure,
case
yeah,
you
yeah,
want to
we'll
jump
do that
into the.
definitely. All right, so yeah, obviously, parrots can process very complex ideas in their head. So something else that some parrots have been known to do is tool use and manufacture. Yeah, they can make and use tools. Um, Now, this isn't super common in parrots, and this is probably because that kind of very curved beak structure that they have is not super adapted for using tools. But nonetheless, some parrot species have been known to use tools, um, and and also making tools as well. And so this was particularly well documented in a species called the Tannenbar corella, also called the Goffin's cockatoo. And so this is the kind of white cockatoo I can see pictured in some of the images here. And so in the middle on the top, you can see an experiment done with these cockatoos in terms of their tool using abilities and tool making abilities. But I guess just as a bit of background, it's quite interesting that tool use has been so well studied in the species because they aren't actually known to use tools in the wild. The reason people found out that they could use tools is because of a captive member of the species at a research lab, I think, was like just happened to be seen using tools. And what he was doing was that I think he was playing with a rock or something within his enclosure, but then the rock kind of fell out of the enclosure onto the beyond the fencing, I guess. And so he decided to use a stick to poke it out of he would poke a stick out of the enclosure and then use it to kind of move the pebble back towards him, and then so he could reach it again. And they were like, "Whoa!" The researchers were very surprised by this, and so they did a few experiments where they decide to leave nuts outside the enclosure and then see whether the cockatoo would repeat this behavior again, and he did. He use sticks to get to the nuts and pull them into the enclosure where he could eat them. Um, and furthermore, he used he made these tools as well. Like he would bite basically splinters off the wooden kind of railing that surrounded the enclosure, and then he would bite them down to a length that was suitable for reaching the nut, and then use that as a tool. And so yeah, that was a very surprising behavior when it was first discovered. And so since then, I think the same research group has done a lot of experiments with this type of cockatoo. Um, and so one of the experiments I pictured here, which is the ones with where these cockatoos are using these green pipe cleaners as tools. And so uh, this experiment was basically testing kind of their flexibility in tool use. So they gave them these pipe cleaners to use, and then they had to try and get food out of these tubes, so either vertical tubes or horizontal tubes. Um, and so with the vertical tubes, the researchers only provided the cockatoos with straight pipe cleaners, but it would be easier for them to get the food if those pipe cleaners were bent into a hook, because they could stick the hook down into the vertical tube and then kind of pull the piece of food up, right? And so it turns out the cockatoos did exactly that. They would bend these straightened pipe cleaners into hooks and then use them to get to the food. Um, but if they were given bent pipe cleaners with horizontal tubes, uh, they would do essentially the opposite. They would straighten the pipe cleaners out because it's easier to kind of use a long enough, long straight pipe cleaner to poke the food out from the other end of the horizontal tube, instead of using a bent pipe cleaner for that purpose. And yeah, they were also able to figure that out as well. Um, so very, very impressive indeed. For some examples of wild parrots using tools, I know there's a species called the greater Vasa parrot, which is one of the Afro-Eurasian parrots, which has been known to use stones to grind up seashells into powder, and then they'll basically eat the ground up seashells as extra calcium. Um, and There's also another species of cockatoo called the palm cockatoo, in which the males use sticks as part of their mating display, and so they will beat sticks against like hollow tree trunks, like almost like drumming basically, and then use that to put on a performance for the females. So yeah, that's another example of tool use in wild parrots. So yeah, that's also pretty cool. Um, Also done on another kind of a study that was done on the tandem bar gorillas was this study that is pictured in the sequence of images on the rightmost kind of sequence of little images. And so this was testing their ability to uh, problem solve sequentially. And so what they did here was that the researchers put food into a box where there was a little window where the parrots could see, oh, there's food inside there. But then they put a series of different types of locks on top of the box. So the parrots would have to like solve all these different ways of opening these locks before they could get to the food. And so the sequence of images is showing all the different steps that would be needed basically. So on the top one, so the first step, they had to remove a pin, and then let's see, then they had to undo a screw, and then they had to flip a bolt, and then they had to turn a wheel and then undo a latch, and then finally they would be able to open a box after that and get to the food. And so it turns out that one of the parrots was able, just by examining the box, to figure out all of these steps entirely by himself. And get to the food. And the other parrots in the study, or at least many of them, they weren't able to figure out the whole sequence by themselves. But after observing other parrots do it, as well as kind of exploring like different elements of the box separately. For example, if the researchers provide them with just the wheel, for example, or just the pin or whatever. After a few exercises with just the individual parts of the puzzle, they were also able to figure out how to open the box. And once they had learned this, they pretty much didn't forget it ever. Like once they had learned how to open the box, they would be able to do it like completely fine in all later trials. And not only that, but when the researchers switched up the sequence of blocks, the parrots were also able to adapt to those as well. They weren't just fixed into this one pattern of doing things. They could figure out, okay, I need to do this because this is a different type of lock from the previous one. So they were able to adapt to that as well. So that's also pretty impressive. And so yeah, that study also kind of includes the social learning by emulation that I listed here, and there are other examples of that too, where parrots manage to learn and pick up different skills by examining or observing other parrots do it. All right. Anything you want to add to these experiments?
Not really, no.
All right. So, and then finally, there have been a few studies that have been done looking at kind of social intelligence in parrots, like whether they can cooperate with each other or help each other and things like that. And so there have been studies done on cooperative problem solving in parrots. So basically, parrots were given this food dispenser where it takes two birds pulling on the strings at the same time for the food to be dispensed. And yeah, the parrots were able to figure that out, and they were able to cooperate with each other to get the food. Um, so that's a sign of a cooperative problem solving. And uh, there was also a study that came out last year that found that African gray parrots specifically um, also engage in voluntary assistance of other individuals of their species. And so that's actually the experiment that's pictured on the lower left on this kind of collage here. And so the way this experiment was set up was that these parrots were trained to use tokens in exchange for food, basically, to exchange for food with the researchers. And so, they would put these parrots into containers where there's this open circular hole on the side, right? You can see that here. And so the parrot can pass tokens out from the hole into the hand of a researcher, and the researcher would reward them with food when they were given the token. Um, and so they did an experiment where they put two parrots into this type of enclosure, but only one parrot was given tokens to exchange food with, and also the kind of window for exchanging food was blocked up in the parrot with that had the tokens, and so the parrot itself could not use the tokens to exchange for food in that moment. But there was another parrot in the enclosure next to it, where it did have an open hole for exchanging food, but it didn't have any tokens to exchange for food with. And it turns out that the parrots, in this situation, they would voluntarily transfer some of the tokens to the other parrot that didn't have any, and so it could use them to exchange for food. And they did several different trials with different kind of variables in this study. So, for example, they tried blocking up both of the holes to see, were the parrots just passing the tokens back and forth for fun or something like that. And well, that didn't happen. And they also tried, for example, blocking up the hole of the parrot that didn't have any tokens. So yeah, again, like would the parrots pass the tokens over if the other parrot had no kind of practical use for the token? And the answer was also no. They only did this, or they did this significantly only when in this particular setup when the other parrot had the opportunity to use the tokens but didn't have any itself. And they also did this more commonly when the individual parrots concerned were like already basically knew each other well and were friends basically. So kind of like us, they kind of tend to provide voluntary assistance more readily to individuals they already knew quite well. But yeah, that's also a really interesting study. Um, do you have anything to add about kind of parrot cognition?
There's certainly a lot of primate parallels that you had
Yeah,
alluded to before, especially in a lot of these later studies with the social learning.
right.
Yeah, I think the comparison is quite appropriate.
Excellent. Yeah, I think so too. So yeah, definitely a lot of parallels to primates, um, and I think it's important knowing all of this to think about kind of our interactions and relationships to parrots, because parrots are very popular pet animals, right? Um,
Hmm.
but realizing that they are so socially and cognitively complex, I think people need to know that uh, keeping a parrot is a huge responsibility, um, and this is an animal that essentially has the emotional maturity and mental uh, abilities of a toddler. Um, and in cases of especially the larger parrots, they can live for decades. So, like, keeping a parrot is basically taking up a huge responsibility. Like, you are basically taking care of a toddler potentially for several decades, providing it with companionship. Um, and this is a toddler that can fly and also has a can opener welded to its face, which it can use very skillfully. Um, so I think all those things combined, it really means that a parrot isn't for like just anyone to keep as a companion. Um, like you really need to know what you're getting into. Um, and there are other reasons to be careful when kind of keeping parrots as well. For example, a lot of parrots are poached from the wild, a lot of parrots in the pet trade.
Mm.
Um, and because of that, a lot of their wild populations are actually under severe threat of extinction. Um, and many of them are mistreated in these conditions. Like they are definitely kept in very inhumane um, situations, and it's really not good. So, you know, if you want to keep a parrot, I'll say up front that I do not personally have much experience with kind of keeping or interacting with live birds. So I'm a paleontologist. I study things that are already dead. But like if you want to keep a parrot, you really need to do your research and make sure that's coming from a reputable, um, ethical source, and make sure that you have what it takes to keep a parrot happy and occupied. And it takes a lot. It's like taking care of a child. So yeah, just know what you're getting into. I know our friends Meg and Max, for example, did a very extensive research before getting their parrots, and I'm sure they do a great job in taking care of them. Um, so yeah, just something to keep in mind. Um, all right. Now, on the next slide, we'll continue a little bit on talking about cognitive abilities because I think something really remarkable about bird cognition is that these kinds of really complex abilities that we see comparable to primates essentially are not only seen in parrots. They also independently evolved in another group called the corvids. So these are the ravens and crows and jays and magpies. Um, so this is a group. They are a group of songbirds, and if that sounds weird to you, that crows and ravens are songbirds, then we'll talk more about songbird evolution in the next episode. But because the next episode is going to have so much material, I think we'll mention the corvids here as as part of this discussion about cognition. I think. Um,
Mm.
so, yeah, corvids are also incredibly intelligent animals. Essentially, most of the things that we talked about parrots being capable of have also been documented in corvids. Now, there currently, so far, hasn't been any equivalent to Alex the parrot for corvids yet, even though corvids are capable of mimicking human speech. Songbirds are also vocal learners, after all. They don't seem to take to it quite as readily as parrots do, and so I don't think anyone has really tried to do a similar kind of experiment with corvids that has been done with Alex. But even despite the language barrier, so to speak, it is very clear that corvids are capable of a lot of very complex cognitive tasks as well. So, for example, they are also known to use tool use. They also have very complex social lives. A very well-known experiment studied the ability of corvids to recognize human faces, individual human faces. And so what they did was that the researchers put on these masks while they were like doing experiments with the corvids. So, like for example, when they were climbing up to the corvid nests and tagging them and such. And of course, the corvids didn't like that. The crows didn't like that. And and so it turns out that whenever anyone, like not just the researcher, but anyone wore those specific masks on in the area, the corvids would come and kind of scream and yell at them and basically try to drive them away because they recognized those masks and know that these were the people who were like disturbing their nests and such. And furthermore, um, crows that had not even been born yet when those experiments took place learned this and would pick up on this from the other crows, and they would also join in this kind of mobbing behavior whenever they saw those masks, because yeah, they have this social transmission. Like they learn from the other crows that, oh, those are the bad guys, let's go after them. And so yeah, that's yeah, quite incredible social transmission of information there as well. um, so yeah, essentially, both crows and parrots are capable of very similar kind of cognitive abilities, and they seem to have evolved this independently, which is really remarkable. So, how do they compare anyway? They're so similar in their cognitive tasks, and there was a really interesting experiment that was published in 2011, and what they did was that they got two different species, so one species of parrot and one species of crow, and exposed them to this puzzle box that they had to solve to get the food inside. And they documented kind of similarities and differences in how these birds solved this puzzle box. And so this box, which is pictured in the images here, um, has three different ways for the bird to get to the food inside. So there's a little window with a latch on it, so the birds could pull the window open and stick their head inside to get the food. So that's one way. Um, Another way would be to take a ball and insert it into one of the openings in the box, and the ball would roll down a tube and knock the food down and then make it available to the bird. Um, Another way would be to insert a stick through another opening and then knock the food off out of the box. Um, and then a fourth way is pulling a string that was attached to the food and then also remove the food from the box. And then every time one of these birds figured out how to use one of these solutions, the researchers would block off that particular solution and force the birds to use a different solution to the puzzle, basically. So that's a pretty interesting experiment. So what did they find? Well, it turns out that at least one of the Kia and at least one of the New Caledonian crows that they studied were each able to figure out all of the different solutions to get to the food in this puzzle box. But what was interesting was how they picked up on these skills, because it turns out that the Kia were generally able to pick up these different solutions more quickly than the crows could. So they were a lot more curious about the box. They did a lot of exploring. They would poke around the box with their beaks and, what does this do? What does this do? They would do a lot of that kind of thing. And in fact, the researchers had to like anchor the box to these platforms because otherwise the Kia would try to knock the boxes over and things like that, basically cheat the system. And in fact, in one case, I think one of the Kia actually broke the box itself. And so, yeah, they they really do explore things a lot like toddlers do. They'll like smash things up and just to see what happens. And so the Kia were generally able to pick up on these solutions more quickly. Whereas the crows were a lot more cautious about it. So even though at least one of the crows was able to figure out all the solutions too, they tended to kind of more wander around and look at the box, and they were kind of averse to directly touching it. And even when they did, they kind of did it very differently from the Kia. So the New Caledonian crow is a species that uses tools in the wild and also makes tools in the wild. It'll use sticks or like tough plant fibers to like poke for beetle grubs hiding inside crevices in tree bark, for example. And so when the researchers provided them with sticks for one of the puzzles, for one of the solutions to this puzzle box. The crows, they would use the sticks, and they would kind of like probe the box with the sticks themselves instead of directly touching it, touching the box themselves. And for example, even with the window opening, for example, the window opening, all the crow had to do was, once it had opened the window, was to stick its head inside and grab the food directly. But the crows tended not to do this, and instead, once they had opened the window, they would still use a stick to kind of poke the food off. So yeah, it seems that they tend to kind of stick more with what they know, basically, and so they're a lot more the technical term is a neophobic, so they're kind of more scared of things that they don't immediately aren't immediately familiar with. So they're a lot more cautious in their kind of exploration. But even so, they are smart enough to figure out all the different solutions to the puzzle in the end. And so that was a really interesting study, I thought. So again, like the purpose of the study was not really to see whether parrots or crows are smarter, but to compare the kind of their problem solving skills and processes. And it certainly did a very good job of doing that. So I've always thought that was a really interesting study ever since I first learned about it. So yeah, that's two ways to make an intelligent dinosaur, and both of those groups are quite successful today. So do you have anything to add to this?
I think also just fascinating that they're also like quite closely related too,
They are, yeah.
which is very interesting.
Yeah, indeed. So it is true that the extremely complex kind of problem solving abilities are probably convergent, but it's certainly not out of the question that, the last common ancestor of songbirds and parrots was probably already a reasonably pretty brainy bird, I guess you could say, and that it already had sort of the foundations to be able to evolve into these two different highly intelligent groups. Alrighty. Um, and before I move on, I'll just mention that if you want to learn more about corvid cognition, since we haven't had much time to talk about it in this series, a good book to consult for that is a book called The Gifts of the Crow. It has
Mm.
all kinds of really interesting reports and about not only experiments but also anecdotes about how smart corvids can be. And it's written by two corvid researchers. And it does, I will warn that it does get a little bit maybe technical at parts because it also goes into some detail about like brain structures and neuroscience and things like that. But I think it's pretty well interspersed with these like really interesting stories of what corvids are capable of and corvid behavior and such. So it's a pretty good read if you're interested in that subject. All right, but let's continue onward. So yeah, what were the selective pressures that led to these brainy birds anyway? Well, I mentioned that parrots probably originated in Australia. As it turns out, we haven't talked about a songbird evolution yet, but songbirds probably did too. Both songbirds and parrots probably originated in Australia. And that is interesting. So Australia has really interesting ecosystems, as I'm sure anyone with a passing interest in biodiversity is familiar with. But something in particular that might be relevant to this is that Australian plants tend to be very sugary. Like they produce sugary nectar, they produce sugary tree sap. There are lots of insects that feed on this tree sap and then they kind of excrete the sugar themselves because there's just way too much of it. And probably the reason for this is that a lot of Australian soils are not very rich in nutrients. So it's nice and sunny in Australia, and the plants can do plenty of photosynthesis. So they make a lot of sugars through photosynthesis. But because there aren't many nutrients in the soil, they don't have enough nutrients to use in chemical processes and combine with those sugars with. And so there's a lot and lot of excess sugar in these Australian plants. And so that is probably the reason why Australia has become this land of sugar. And with that, you start getting animals that become specialized for feeding on these sugary substances, and that includes a lot of the Australian parrots and the Australian songbirds. Um, so perhaps with this really kind of sugar-rich diet, this is very speculative, but it certainly seems like a plausible mechanism to me. Um, that with this really sugar-heavy diet, probably these birds gained, the energy to be able to evolve these really big and complex brains. Um, and it's probably a very similar story with the primates too. More parallels there. Primates probably a lot of our cognitive abilities probably originated from being these fruit-eating animals in the trees, having to identify different types of fruits and being able to feed on all these sugar-rich food sources. Um, and so probably it's a similar story with the parrots and the songbirds. And furthermore, kind of the parallels to primates are also relevant to another aspect of this, is that there are no primates in Australia, and in fact there also aren't many other mammals that would otherwise compete with the birds for these sugar-rich food sources. There also aren't any squirrels, for example, in Australia. Um, and so perhaps because of this, the birds had a lot of these sugar-rich foods essentially more or less to themselves. Well, they had to compete with other birds for it, but the competition was reduced. And so perhaps this also gave them the resources to evolve those big complex brains. And furthermore, uh, this kind of environment also probably promotes complex social behaviors. And the reason for that is in this kind of nutrient poor landscape, sometimes there are years when uh, there just isn't enough food for all the birds to breed together at once. And probably because of this, a lot of Australian songbirds are what we call cooperative breeders. So a lot of the time, the young, even after they've matured to adulthood and are old enough to breed for themselves, they will actually stay around with their parents, and then they help their parents with next year's their younger siblings, basically. Um, and probably a big part of this is because it is not always advantageous in this kind of environment to go build your own household, basically. Um, it might be better to stay around at home for a little bit and help out the parents until you get a better year for breeding. Um, and so, because of this, you start getting more complex social structures involved, where big extended families all live together and all help out in the various tasks that are required, whether it's a nest defense or feeding the young, and also kind of protecting these very valuable food sources from other groups of birds. And in fact, there are a few groups of Australian songbirds that are super reliant on this cooperative breeding behavior. Basically, they cannot breed successfully without a large group of family members to help out, because they are just so specialized for this. Um, and with these complex social structures, you probably get selection for complex communication as well. So, complex ways of communicating concepts or songs that you learn from your own species, or calls that you learn from your own species for specific purposes. Um, and all of these factors combined, probably gave rise to really intelligent birds that we now see today. So I should mention that corvids specifically probably did not originate in Australia, but songbirds in general did, and eventually some of the corvids, after originating outside of Australia, actually dispersed back into Australia, and so now we actually have Australian corvids as well. But probably the ancestors of corvids might well have benefited from this kind of complex myriad of factors that were favorable to giving rise to highly complex cognitive skills and complex social structures and complex vocal communication. So that is really fascinating. And if you are curious in learning more about the evolution of Australian birds, I really recommend a book by an ecologist, I believe, named Tim Lowe, who called Where Song Began. And so that's a book about the evolution of Australian birds, and the title refers to the fact that songbirds probably originated in Australia. And so he talks about that, but he talks about a lot of other really fascinating aspects of Australian ecology and evolutionary history as well. And so it actually is like not just one of my favorite books about birds, but also one of my favorite books about evolutionary biology in general, and I highly recommend it. But yeah, that's a rather speculative and hypothetical premise for the evolution of intelligence in these birds, but I think it's a pretty good working hypothesis. How about you?
No, I definitely agree. I mean, you when it comes to hypotheses like these, I mean, you got to start somewhere.
Of
And
course.
I think the accumulation of observations and evidence that we have for a lot of these behaviors, ecologies, species, for example, I think lends this hypothesis a lot of really good support.
Mm.
Um, I guess just time will tell regarding more remains from the fossil record to help seal the deal on this case.
Yeah, definitely. Yep, it would be nice to find more fossils in Australia that shed light on the issue, because yeah, we have a number of bird fossils from Australia, but a lot of the kind of early time periods that we're interested in, when a lot of this might have been occurring, it's pretty scanty. But there definitely are people working on it, so yeah, we'll find out. um, Now, finally, on the next slide, I have a few other things to say about evolution of like cognition and brain size in birds. And so this is from a study from last year looking at the evolution of avian brain size. And in fact, they also included some data from stem birds in here, so a number of non-bird theropod dinosaurs okay, for comparison and to figure out what the ancestral kind of states were. And so they found some pretty interesting patterns. But I guess just to explain what you're looking at here, on the left is a phylogenetic tree showing kind of the relationships between many of the groups they looked at. And you can, if you look closely, you can probably see little arrows on the branches here. And so you might not be able to make it out so well in the video slide. Check out the paper if you want to see these more clearly. But just to explain here, the white arrows represent body size, um, and the black arrows represent brain size. And so arrows that go up means that either body size or brain size becomes larger, and arrows that go down means that those things become smaller. And if you see two arrows in for some of these, that means that one of these factors is increasing or decreasing more quickly than another. And so, for example, at the very base of the tree here, or not the very base, but closer to the base of the tree here, you can see that in Paravian dinosaurs, in the group of dinosaurs, including birds and their closest relatives, or some of their closest relatives, both body size and absolute brain size decreases, but there are two white arrows there, so body size decreases faster than brain size. And so this actually gives Paravian dinosaurs relatively larger brains compared to their ancestors, even if the absolute brain size is becoming smaller. Does that make sense?
Yeah.
Yeah. So you can see a lot of the kind of transitions they identified here in body and brain size. And on the right here shows relative brain size in different groups of birds and also non-bird dinosaurs as well. And so you can see that a lot of the birds towards the bottom of the phylogenetic tree, as pictured here, have some of the largest relative brain size among birds. And you may or may not be able to read the names too clearly here, but the bottommost the bottommost kind of red string of dots down there, those are the corvids. So they have some of the largest brain sizes among birds. And then the kind of the third red string up there from the bottom are the parrots. So ignoring the two orange strings in the middle. So the third string of red dots counting up from the bottom are the parrots, and so they also have very large brain sizes by bird standards, relatively speaking. Um, and so, yeah, I know relative brain size is sometimes overstated as kind of a metric of intelligence. Um, but nonetheless, I think the trend is fairly clear here that the two groups of birds that we consider to be very intelligent also happen to have the largest relative brain sizes. You might also see another group some ways up there that I think that's a blue string up there with also very large brain sizes. So that group is actually the owls. However, the parts of the brain that make the owl brain size so large seem to be more related to like sensory processes, perhaps,
Mm,
which makes a lot of sense for owls. And so that may not correlate as much with like kind of problem solving abilities, but still, it's interesting to take note of that. Um, and so something else I'll draw attention to here is that it turns out that the large relative brain sizes in corvids and parrots probably evolved through very different processes. So again, two ways to make an intelligent dinosaur. And so
right.
it seems that in parrots, according to this study at least, what happened was that the body size of parrots decreased relative to their ancestors. And so it's kind of similar to what happened at the base of all Paravians. That gave parrots higher relative brain sizes, larger relative brain sizes, because the body size decreased faster than the brain size was decreasing. And so they got bigger brains because of that. Whereas in corvids, both body size and brain size increased, but the brain size increased faster than body size. And so that ended up having the same effect, but they got bigger brains by becoming bigger instead of by becoming smaller. So that's really interesting. And indeed, corvids include some of the largest known songbirds in the world. So yeah, that is super cool. Um, I guess one final thing I'll mention for this is that even though these really smart birds have really large relative brain size, um, their absolute brain size is still quite small. Like, an African gray parrot still has a brain that's only about the size of a walnut or so. And so it is still really remarkable that they are capable of such primate like cognitive processes. Despite that. And so a couple of years ago, more than a couple now by this point, but a few years ago, a study came out that found something really interesting about bird brains, and is that the neurons in bird brains are very tightly packed, or very densely packed, much more densely than in mammal brains. And so it turns out that in a parrot or a crow, there can be the same number of neurons in the brain as, say, a monkey does, uh, even though in absolute brain size, the birds have much smaller brains. And so that probably, I suspect, is a big reason why you can kind of get these really smart birds in these relatively small packages. So yeah, that was a really cool finding. There are many, many, many other studies that have been done on kind of avian cognition, and it is a super fascinating subject. And in fact, I think really I'm not the right person to be talking about a lot of these subjects, because a lot of it has to do with like kind of neuroscience and processes of the brain that I am personally not super familiar with. But there's a lot of fascinating research that is done on it, and so there are, if you want to learn more, there's plenty out there for you to look through. Do you have anything to add about this subject?
Well, I think well, I mean, I'm excited that you were finally able to talk about this study because you had alluded to this earlier when we looked at the mammalian brain size study
Oh, right.
in our news episodes. So it's kind of cool to actually see this here and like compare all the different relative brain size measurements here. Um, but yeah, I mean, other than that, not really too much to add. I think studies like this also kind of, I guess, just kind of reiterate that it's not so much the size of the brain that correlates with intelligence. It's like what parts of the brain
Right,
are used for like cognition. And I
right.
think the owl example here that you talked about, I think it beautifully illustrates
Mm,
that.
right, right. Yeah, definitely. And yes, I actually forgot about that. Yeah, I did mention this study during that episode, didn't I? Yeah, no, it is really great to be able to talk about. I thought it was definitely a really cool study. Um, Alrighty then. But with that look at bird brains, I think we can continue onward.
Sure.
Um, So we're going to talk about kind of the extinct parrots and the evolutionary history of parrots from the fossil record. Um, and so I guess having spoken so much about parallels between parrots and primates, I think another notable but rather sad parallel between parrots and primates is the fact that so many parrots are under threat of extinction, just like a lot of the wild primates are today. Um, and probably for very similar reasons. Like these are very long-lived animals that breed slowly and take a long time to be able to pick up all the skills that they need for survival. And so, if there are strong pressures that are kind of hastening their their death rate, such as habitat destruction or poaching from humans, um, then they can very easily undergo rapid population declines and potentially go extinct. And
Mhm.
so, sadly, there are quite a large number of rather recently extinct parrots that were driven to extinction in historical times. And so you actually mentioned one of them earlier. So this is the Carolina parakeet that I pictured on the right here, that lived in the eastern United States, and it lived in massive, massive flocks. Like it was a super gregarious species that would gather in these huge flocks, and was super abundant. But eventually, it did indeed die out. Um, you actually covered a lot of aspects about what we know of its biology pretty well earlier, um, but I'll just add to that here and say that it is actually a bit of a mystery why the Carolina parakeet went extinct. So it is true that people were killing a lot of them. So certainly that probably didn't help, and there was habitat destruction going on. However, people have pointed out that at the time of its extinction, there probably was still a fair amount of suitable habitat left for it to live in. So it's not immediately evident that this would have been the thing that drove it to the brink.
Hmm.
There have also been people who suggested that maybe disease was a factor, that there was just some big disease that happened to wipe them out. However, there is also no very strong evidence of that either. So it is not clear, but probably, if I had to guess, it was a combination of factors. Like
Mhm.
maybe no one of those factors by itself would have been enough to drive it to extinction, but perhaps all of them together eventually took its toll. And I might suspect that maybe a lot like the passenger pigeon, maybe the Carolina parakeet was a species that required being in such large numbers to thrive, like just socially and biologically. It relied on being as part of a big flock to live as an essential part of its lifestyle. And so perhaps once their numbers dropped below a certain point, like even if they weren't being directly killed by these anthropogenic factors, they just couldn't hang on anymore because they relied on being in those big flocks. So perhaps that was a thing as well. Um, and yeah, so that's how we lost our American United States parrot. Um, there's another species of parrot that once ranged a little bit into the U.S., and that's the thick-billed parrot. But it unfortunately has also been driven to extinction within the United States. It does still survive in Mexico, but yeah, no more native parrots for us. Um,
Right.
but yeah, and yeah, it is true that the last Carolina parakeet died out in the same cage that housed the last passenger pigeon, which is kind of an eerie and unfortunate coincidence. But in other parts of the world, parrots haven't really been spared either. So one example that I'll give here is the broad-billed parrot from Mauritius. So this is a parrot that lived in the same ecosystem as the dodo, um, and so this was a rather large parrot species. Like it wasn't as big as the kakapo, I think, in terms of body mass, but it was rather hefty, and is notable for its really big head relative to its body size. You can see in the sketches here. So these sketches were done by someone who had seen them in life, um, and so they had these big heads with huge bills. So probably they were very good at cracking open giant nuts to eat. And it probably wasn't flightless, but it most likely did have reduced flight capabilities. It was said that it was very reluctant to fly, at least. And something interesting about the broad-billed parrot is that it was originally named scientifically based on like subfossil material, so material that was of already dead birds that it was thought at the time that no one had ever seen alive, at least no Europeans had. But it was later found that, oh, there were these records of people had been to Mauritius that talked about this giant big-headed parrot and even included a sketch of them. And so it turns out that, yeah, this was the same species as this species that was originally named based on fossils. And so I show some remains of this parrot in the bottom left here. And so those kind of horseshoe-shaped bones below are the lower jaw of these parrots, and on top, those kind of more flattened pieces of bone are palatine bones. So these are a bone in the palate of these parrots, and you can see that in one case, one set of bones is substantially smaller than the others, and it is thought that probably this might be a case of sexual dimorphism, where the males perhaps were much bigger. Um, so yeah, a rather unusual species of parrot that unfortunately is no longer with us. But yeah, these two parrots are just a few examples. But there are a few things to say about parrots that went extinct in more distant times and that we only know from the fossil record. Do you have anything to add about recently extinct parrots?
Not particularly, but I'm excited to look at some of the older species this time.
Sure, sure. Excellent. Some of them are quite fascinating, and as we will see on the next slide. Um, so, for example, I'll first give an example of um, a New Zealand parrot that is extinct.
Mm-hmm.
So, this is a parrot that is known from the Miocene of New Zealand, so it's about like I think like 17 million years old or so. So it's known from a fossil site where a lot of bird fossils have been found. So it's really given us a good look at kind of the history of birds on New Zealand. And we actually also know of some smaller parrots that are probably similar to like the kaka or the kia from this fossil site. But certainly the most spectacular parrot that has yet been discovered here, and one of the most spectacular birds in general that's been found at this fossil site, is Heracles. Yeah, which was a giant parrot. So it is only known from a few bones. So a picture here, the brown bones on this picture here are the hind limb bones from this giant parrot, and the white bones are from the kakapo, which is a New Zealand parrot and the largest living parrot. And you can see how much bigger the bones of Heracles are compared to the kakapo. And they also put on a hypothetical size comparison next to a human in silhouette form up there. So yeah, this was a huge parrot, like probably the size of a turkey or so, and the largest parrot that we currently know of that ever lived. Um, so yeah, pretty impressive animal. We don't know too much about its biology, what it was like. So yeah, not much we can say for sure on that front, but certainly a very impressive animal. Um,
I'm actually kind of surprised that it took this long for an animal of any type to get the genus name Heracles.
yes,
Because for those of you who aren't aware, Heracles is the Greek name for Hercules.
that's right.
That often gets confused a lot because Hercules is more well known as a name. But no, that's if you're dealing with Greek times, that's how you would say it,
That's
Heracles.
right. Yes, exactly. Yeah, that's right. I was surprised too when this came out. Like, wait, no one has used that as a genus name for an animal yet? Yeah, well, apparently not.
Because I know about it, I mean, being used as a species name. I mean,
Right.
using the Roman version. I mean, there's that giant beetle from South
Mm,
America, Dynastes Hercules, which is a rhinoceros beetle, which is
naturally.
a pretty impressive animal on its own. But yeah, like genus wise, like no. So this is kind of a neat thing that okay, now we can cross off that list from
Right.
all the Greek classic Greek names.
Indeed, indeed. Yeah, no, that is quite interesting. So yeah, it's the largest parrot that we know of, and it also shows us that New Zealand had already been colonized by parrots by the early Miocene. So yeah, pretty neat. All right, so let's go on to the next slide. And so over here, we're looking at a few sketches of a fossil tarsi from parrots. So these are the fused ankle and foot bones. And what's quite interesting about these parrots is not how complete they are, because they're not really complete at all. They're mostly known just from these bones. And these are all Miocene in age. But the fact that all of these were found in Europe. So yeah, there were these at least these four different species of European parrots all living in the Miocene. And so I said earlier that today we don't have any native parrots in Europe, but that hasn't always been the case. There used to be these Miocene parrots, and quite a large number of them too. Um, Now, this probably relates to what we talked about in episode 11 regarding kind of range contractions of birds throughout the Cenozoic. Um, and yeah, certainly this seems to fit with that pattern. Parrots are a group that is primarily tropical, probably prefer warm climates for most part. And so probably these European parrots died out as the climate became cooler and drier throughout the Miocene. Um, but for a while, they were doing pretty well, and so kind of adds to our kind of record of birds that formerly had much bigger global distributions that were most likely impacted by these climate changes. So that's pretty interesting. What do you think?
No, definitely. It's kind of one of those things where, I mean, like we've talked about this a lot already, but
Mhm.
it's still it's surprising, but it's unsurprising.
Right.
Like, it's unsurprising, like, well, yeah, of course, because these environments have changed so much over time, and
Yeah.
tropical Europe would house tropical birds like parrots. But it's just the fact that that's been confirmed by fossils like these,
Right. Right.
especially in places like where I don't think you'd catch a parrot dead in the wild.
Yeah.
Like the Czech Republic of all places. Like
Right.
that's amazing.
Yeah, definitely. I guess I'll also say for the record that because of the kind of very incomplete nature of these fossils, we're not sure how these particular parrots are related to the living parrots. So where they fit in the phylogeny is not really known. Um, but just in terms of general anatomy, um, most of these parrots seem to be similar to the Afro-Eurasian parrot groups, um, whereas the one from the Czech Republic, labeled letter G here, Xenocita, um, it actually seems to be more similar to the American parrots. So, yeah, who knows? We do know, of course, that there are some of the members of the American parrot clade that live in Africa today, so it's certainly not out of the question that some of them could have spread into Europe at some point in their evolutionary history. But yeah, hopefully we find more complete fossils of these parrots at some point, because it would be great to be able to learn more about them. All right, should we go on to the next slide?
Yeah.
All right, now we're going to go even older, back to the Eocene, and these are also what seem to be European parrot-like birds. And so um, there are a couple different species of this genus called Quercicita that have been named. The comparisons here, they're not showing the same bones. So on the left here is the coracoid, one of the shorter bones from a Quercicita ivani. Um, Whereas on the right there are tarsimetatarsi from a different species of Quercicida called Quercicida sudrii. But both of them are known from the Eocene of France, and they're mostly known from isolated bones like this, so we don't know too much about what the whole birds look like. But they do have a number of parrot-like features. The foot is certainly very parrot-like. Um, However, these do not seem to have been crown parrots, so these seem to have been stem parrots. Um, and one of the big differences that they have from crown parrots is actually labeled on this slide here. So the text here says the cup-like scapular cotyla on the coracoid. And so what this means is that basically this is the socket where the shoulder blade fits into the coracoid. So both of these are bones of the shoulder girdle, and so they're connected to each other. In most birds, the standard condition is having this a deep cup-like socket for the shoulder blade in the coracoid. Um, However, in crown parrots, there's actually only just a sort of flat surface where the shoulder blade attaches to, and so it seems that Quercicita, if it was a close relative to parrots, it probably was not a crown parrot. Um, but uh, but yeah, probably more likely a stem parrot because it has this ancestral feature. Um, But yeah, it is quite interesting because it does show us that it seems that at least by the late Eocene, which is when these fossils are from, there already were stem parrots like outside of Australia that had made it to Europe. So that is quite interesting. But other than that, we don't know too much definitively about the kind of Eocene or Paleogene record of the parrot lineage, kind of a parallel to falcons there, as you can see. Um, so it still remains fairly mysterious, but there are a few birds that are known from the Eocene that seem to have something to do with parrots, and yeah, a few mystery birds, as we shall see. Um, uh, but before we head on over there, do you have anything to add?
No, not really.
Alrighty, so yeah, let's go and look at some of these parrot-like fossil birds, but we have some open questions about their phylogenetic relationships. Um, so first up are a group called the halcyornithids, and so this is a group of mostly pretty small birds, like they're about the size of a thrush or smaller than that. Um, and they're known from several fossil sites in both Europe and North America. So they're known from both the Messel and the Green River formations, both very good fossil sites for bird fossils. Um, and only known from the Eocene so far. And this is one of the most complete skeletons that have been found from one of these birds. This is Cirrolavis colburnorum from the Green River Formation in the United States. Yeah, this is a pretty interesting bird. Um, now, kind of similar to parrots, they had zygodactyl feet and very short tarsometatarsi. However, their skulls are quite different from modern parrots. You can see that the shape of the beak is very different. So the beak is quite short and stout, but it's not really hooked at all. It has a rather straight kind of shape. And so probably these weren't exactly cracking nuts and seeds like a modern day parrot would. Maybe they were a bit more generalist feeders, like eating some plant material, but also some insects as well. They do have some interesting parrot-like features, and in many recent papers, it has been considered that maybe these were a group of stem parrots. So they were on the parrot lineage, but not part of the modern parrot radiation. Um, However, more recent studies have suggested that they might not, strictly speaking, be on the parrot lineage. Um, so, because it wasn't until recently, with a lot of the big scale genetic studies, that we realized that parrots are most closely related among living birds to the passeriform birds, right? And so, in a lot of previous phylogenetic studies, this hasn't really been taken into account. In fact, the position of parrots has been really uncertain prior to a lot of these genetic studies. Um, but now that we know that parrots and passeriforms are actually closely related, more recent analyses have tried to include this as an assumption when they run these analyses. That, okay, you have to put the parrots next to the passeriforms because we know that's most likely where they go. And when you run analyses like this, and also include things like the halcyornithids, and also sample a lot of the other teleravian groups, it turns out that the halcyornithids are often not resolved as stem parrots, but instead as stem psittacopasserins. So that is a clade that unites the parrots and passeriforms, but not the falcons. And so it may be that the halcyornithids were not stem parrots, but were instead equally close to both the parrots and the passeriforms. And that is interesting because that seems to suggest that a lot of their parrot-like features are probably actually ancestral to the entire kind of parrot and passeriform clade. Um,
Hmm.
then, yeah, there's definitely some interesting stuff we could say about their evolution there. Should we go on to the next group?
Yeah, definitely.
All right. So the next group is a group called the messelasturids, and they are also known from both Europe and North America. Um, Now, they are generally a bit larger than the halcyornithids. They're still not huge. I would say they're around, like maybe the size of a small pigeon at best. Um, but yeah, a little bigger than the other ones that we just talked about. Um, and yeah, they're also known from places like both the Meso and the Green River Formation, and in some cases known from pretty complete skeletons. So this is one of the best known species. This is Messelastor from the Eocene of Germany. In terms of their feet, it seems like they weren't fully zygodactyl, so their outermost toe did not point fully backwards, but instead they were semi-zygodactyl. So probably the default condition was that the outermost toe was kind of spread out to the side, and they could rotate it to be fully backward pointing when they felt like it, which is a condition that we see in some birds today, like owls and turicos. Um, Something pretty interesting about the messelasturids is that they have some rather raptor-like features, you could say. So, first of all, the beak is quite sharply hooked, um, and they have this rather deep kind of lower jaw, and they also have these kind of bony, like almost like eyebrow ridges, like over their eyes. And actually, so did the halcyornithids, for that matter. They also have these eyebrow ridges, which a lot of raptors have. And in fact, when messelasturids were first discovered, they were thought to be like, oh, maybe these are like early hawks or maybe early owls or something like that, because of these raptor-like features. However, more recent studies have found that they are similar in many ways to the halcyornithids in terms of their overall anatomy. And so there came the idea that, oh, well, maybe these were also stem parrots too. But just like with the halcyornithids, similar story. When you run phylogenetic analyses that actually include a large number of teleravians and actually take into account the fact that parrots and passeriforms are closely related, it turns out that a lot of the time messelasturids do not fall on the parrot stem, but in some cases they also fall on the psittacopasserin stem instead. So again, they might be equally close to parrots and passeriforms. Um, in terms of their ecology, it seems possible that messelasturids were predatory birds. So not only because of their hooked bills, but also because the claws on their feet were also quite sharp and hooked, like rather raptor-like talons. So they might have hunted smaller animals. Although we can't really exclude the possibility that they were eating some plant material as well, because of course that kind of deep bill might be pretty useful for crushing like hard fruits and things.
Mhm.
So maybe we're not sure. We haven't found any with gut contents yet. But yeah, another rather mysterious and interesting group of birds. Now, I think the raptor-like features are very interesting in light of the fact that, again, it is hypothesized based on relationships of living teleravians that maybe teleravians descended from a raptorial common ancestor. And so I have to wonder, like, if what we're seeing here is like a stem psittacopasserin that still retains some of these raptor-like features from that distant raptorial ancestor. I think that is pretty plausible considering what we currently know. All right. Do you have anything to add to this?
Um, it's definitely interesting to kind of see, like, should these STEM positions hold out in
Mm,
future analyses? I think it's interesting now that we're kind of starting to see the transitions through the different groups, and
yeah.
it really flushes out a lot of that early history. Yeah, I mean, it would be interesting to see that we get this hypothesis that teleravians may have been ancestrally raptor like birds
Hmm.
or just raptors themselves. um, that when we start including more fossils into these analyses as well as finding new things that we,
Right.
we start to see like in a lot of these groups that are not raptors that at least very early on or on the way to those lineages like
Right.
they're still very raptor-ish.
Yes. Yes.
So I think this is a cool example of that.
Yeah. Absolutely. I completely agree. Okay. So on the next slide, I have a few more examples of these kind of birds have been considered parrot-like, but are still rather mysterious in terms of their phylogenetic position. In fact, the three different birds that I show here might actually all be closely related, so they actually might form this kind of radiation of weird parrot-like birds. Um, Yeah, pretty interesting. So first we have on the left Avolatavis from the Green River Formation of the United States. So it's known from like roughly the back half of its body. There's the hip girdle up there is kind of that big mass. You can see the tail kind of sticking out at the back, and then it's got the hind limb bones. So it's got these very powerfully built feet with a very short tarsometatarsus and probably a semi-zygodactyl feet. And when it was first described, it was also considered okay. So this is probably a stem parrot because of these distinctive hind limb features. But yeah, yet another example. All of these birds, in fact, when they're included in these phylogenetic analyses, these newer ones, they don't tend to fall out directly on the parrot stem. But it's actually still a bit unclear where they would fall because they tend to just end up in a polytomy within a Teleraves. So it's actually not even clear if they are stem psittacopasserines or not. Although I do think that's perhaps a plausible position for them. But yeah, in any case, still a lot we have to learn about these birds. That's for sure. In the middle is Vastan avis. It's known from several species, and some of the bones that have been assigned to it have not been assigned to any specific species yet, so that's why it's like Vastan avis spa on here, species unknown basically. And it's pretty cool because it's from the Eocene of India, which is not a place where we find a lot of bird fossils. But we actually have quite a large number of bones from Vastan avis. Now we don't have skull material, I think, at least not very complete stuff. But most of the major limb bones have been found, and in general, it seems to have been something pretty similar to Avolatavis. And in some ways, it's actually also very similar to the that possible European stem parrot, Quercicida, that I mentioned earlier. So yeah, perhaps this is also something that follows somewhere along the psittacopasserine stem. But yeah, we're probably going to need more data and analyses to figure that one out. And finally, there's Eurofluvioviridavus, a long name there, from the Messel of Germany. And yeah, this one is pretty interesting. As you can see, it's known from a nearly complete skeleton, so that's a pretty cool fossil. But the reason it has a name like that is because it was thought to be closely related to a bird called Fluvioviridavus, which comes from the Green River Formation. And in fact, the name Fluvioviridavus means green river bird.
Aw.
Yeah. Um, and so, because it was thought to be closely related to Fluvioviridavus, the describers named it the European Fluvioviridavus. So now it's Eurofluvioviridavus. But very unfortunately, we don't really think that it's actually closely related to Fluvioviridavus anymore. So I actually did mention Fluvioviridavus in a previous episode of this series, and I mentioned it during the episode on Strisaures, the group that includes hummingbirds and swifts and nightjars and such. And that's because that's actually where we think Fluvioviridavus belongs to now. It has some similarities to a group called the frogmouths, so it has been considered a possible stem member of that. And in a study that I did, I found it as possibly a stem member leading to the very unusual oil bird of South America. So we're still a little unsure about where that species belongs, but in any case, it probably is a member of Strisaures and doesn't have much to do with, say, parrots, for example. And if you need to review the diversity and evolution of Strisaures, you can go back to episode 5. But in any case, Fluvioviridavus probably is a very different bird, unfortunately. Notably, the foot is actually very different. For example, the foot of Fluvioviridavus is fairly typical for a bird foot in terms of the toe arrangement, whereas a Eurofluvioviridavus has these semi-zygodactyl feet. So yeah, seems to be a pretty good sign that these two are not that closely related. And it seems that Eurofluvioviridavus most likely is something similar to Avolatavis and Vastanavis. Probably belongs somewhere within Teleraves, but we're not really sure. So lastly, I'll just mention that we don't know too much about the ecology of these birds. Like, of course, we don't have the head of Avolatavis or Vastanavis. We do have it in Eurofluvioviridavus, and it seems to be a pretty interesting shape with this sort of wide bill. But because it's preserved mostly flattened, we can't make out too many of the details. on the feet, all three of these species are known to have had like rather sharp and curved raptor-like claws. So that might be yet another feature that is retained from a raptorial teleravian ancestor. But yeah, other than that, we don't know too much about these guys. I really hope that we eventually get more studies on them because they do seem quite mysterious and interesting. Um,
Yeah, definitely.
yeah. All right. There is one final fossil I want to show, but do you have anything to add to this?
No, let's see it.
All right. So this is a bird on the next slide called Psittacopes, or Psittacopes, however you want to stress it. This is another a bird from the Messel Formation in Germany, and it's a dinky, tiny little bird. It's like the size of a wren, or maybe even smaller than that.
Hmm.
And so when it was first discovered, it was automatically thought to be this is a stem parrot. And the reason it was thought to be one is because, in terms of its foot structure, it's very parrot like. It seems to have zygodactyl feet. Um, yeah, and people were like, wow, this is really cool. It shows us that this ancestral parrot is pretty different from modern parrots because you can see that the shape of its skull is completely different from what you'd expect from a parrot. Um, but again, once we have these newer analyses and a better understanding of how the living groups relate, it turns out that Psittacopes probably was not a stem parrot. And yeah, in fact, its name means parrot foot. So that's right there in the name. Despite that, as we'll see on the next slide, more recent analyses actually recover it not as a stem parrot, but as a stem passeriform.
Oh,
Ooh, that has some interesting implications, doesn't it? But because I will be covering passeriforms in the next episode, I will go into more detail about Psittacopes and its close relatives, because as it turns out, we actually have a better understanding of the diversity of its close relatives now in the next episode. And so on the next slide, I'll kind of review what we currently think about the phylogeny of the eufalconimorphs in general. So, as we can see here, the falcons and the parrots and the passeriforms are each other's closest living relatives, but there are a number of fossil groups that probably belong to kind of stem lineages within this clade that kind of separate them. And so we have the raptor-like halcyornithids and messelasturids that we currently think might be a stem Psittacopasserans. And then we have this fossil, a Psittacopes, or Psittacopes, that seems to be a stem passeriform and not a stem parrot as we once thought. And we will meet a number of other possible stem passeriforms in the next episode. All right. Do you have anything more to add to this before we wrap up?
I think you've pretty much covered everything that's important to say. I think it's. I've noticed this with a lot of the groups that we talked about over the last couple episodes. Like
Yeah.
it's fascinating that we have so many of these Eocene, Oligocene, Miocene birds
Yeah.
that are such mysteries. And
Mm-hmm.
I think like with our understanding now of where bird phylogeny is at the moment, like the fact that we're actually able to kind of say a little bit more on these different groups than we could have maybe say a decade or two
Right.
ago. I think it's just a remarkable thing, and it's kind of amazing how far we've come in that aspect.
Yeah, I completely agree, and it's a really cool example, kind of reciprocal illumination, as they say. Like understanding the phylogeny of modern birds, kind of gives us a better understanding of these fossil birds, and then knowing where these fossil birds go also gives us a better understanding of how living birds evolve, and I think that's really cool too. And that's something that I hope to focus more on with my own research, and definitely a topic I'm really interested in, just figuring out all these kind of mystery Paleogene birds for sure.
Definitely, and we're grateful for it.
Well, glad you think so. Alrighty, so of course, the next episode is not really a secret anymore, is it? I've already mentioned what I'm going to talk about many times in this episode. So, in the next episode, which incidentally will also be the final episode of Dinosaurs: The Second Chapter, we will finally meet the Passeriform birds, and the Passeriform birds are a super, super, super diverse group of birds. They account for 60% of all living birds, and you're hearing that and you're saying like, what the heck? Because You're finishing up the series and you're saving 60% of all living birds for it. I'm like, yep. Unfortunately, yes. I part of me wishes that weren't the case too, but I will explain my reasoning for that in the next episode. So you just have to wait for that. There is,
Mhm.
of course, a lot to say about the evolution and diversity of passeriform birds. So we'll get more into that next time. And with that, for acknowledgments, we would like to thank our friend Henry for the music and my friend Alicia for the color scheme of my Alvarezor avatar, as always. Um, and if you enjoyed this episode, please follow us on Twitter, where we always update you with whenever we release a new episode. And you're probably watching or listening to us on YouTube. So if you like this episode, subscribe to our channel, and you'll be notified whenever we release a new episode as well. And if you have questions about the show or comments, you feel free to leave a comment. We love receiving comments, or you can send them to our email at timandclades@gmail.com if you don't want to leave a comment on YouTube in the public. As always, we'll include links to references that were used in this episode in the description. And if you like our show, feel free to share around and share with people who might be interested. Finally, we are now on Patreon, as we announced in our previous episode. And so, if you would like to, if you are able and willing to give us a bit of support so that we can keep doing what we do and expand our projects, your contributions will be very much welcome. Um, so I believe at the moment we currently have one patron who is on a tier where they are where we're supposed to mention them on the show, right?
Yep. This my sister Julie Gaines. Um, she been asking me for a long time, like, when are you getting that Patreon up so I can help out? And I'm like, okay, well we'll get to that when we come to it. And so here's your shout out. And we're very appreciative of your support, of course.
Absolutely. Yes, definitely seconded there. Um, so, yep, we appreciate it a lot. But otherwise, um, let's see. Next week, yes. I think, what with like finishing up Humanity a prologue, I think we kind of feel like taking a break next week, don't we?
Yeah, it was a lot of work to put it all together, and I just kind of need some time to rest my head and also just work on other projects, including the updates episode, which I had alluded to in
Mm-hmm.
our finale. We'll be dropping that the following week, so it's not too long of a break. So, of course, you're always more than welcome to go back through our series and rewatch them if you're so interested in. But yes, the updates episode is coming. A lot of really cool new studies to talk about, a couple discoveries, some review papers. It's going to be great, and
Wonderful.
hope you all join us for that.
Excellent, excellent. Yeah, obviously, anthropology is a super fast moving field, and so I'm sure that there will be a lot to say then. Um,
Mhm.
but yes, in any case, hope you all take care, have a good day, and stay safe, everybody.
Yep. Take care, everybody.